Hi, good morning, good evening, good afternoon, wherever you are. This is Microsoft JDConf, and I'm Bruno Borges, your host. Today, we're going to have a series of sessions about Java, cloud, and AI. And I'm here from Vancouver, Canada, to drive this America's edition. But I can see on the chat we have lots of folks from everywhere. And I'm pleased to welcome you here, and thank you for joining us on this, to me at least, rainy day. Hopefully it's sunny and sunshine on your side, or full moon, whatever you are. It's the third edition of Microsoft JDConf, and so far we've had lots of amazing content that you can go back to JDConf.com and visit our Microsoft Java developers on YouTube to watch recordings from past editions. And be assured, all the sessions from this edition will again be recorded and posted there as well, so you can watch again, or if you missed something, you can go back and watch them later. It's a special JDConf because, of course, you're going to talk about AI. Of course, you're going to talk about cloud. And of course, most importantly, you're going to talk about Java, because you are a Java developer at the end of the day. You write Java code, and you integrate with things, and you make bugs, but then you go and fix them. So it's all good and fun. And today we're going to have lots of speakers to help you potentially write less bugs, but even better, write amazing new tech, amazing new scenarios and use cases, integrate with artificial intelligence and machine learning and large language models and ChatGPT this and AI that. But before we dive into that, let's just review our code of conduct, because there is a chat in this event, and we welcome everyone to participate, but please behave yourself, be kind, and be nice with others, and respect our code of conduct as part of this event. That said, we have a great agenda for today. We have about 6 speakers in the keynote with Julia Liuson, our president of developer division and GitHub. And she will talk to us about how Microsoft is investing in developers in general, but also Java developers, and how GitHub is evolving to allow developers to be more productive and more agile and work faster. So besides the live event, there is a set of on-demand sessions that got pre-recorded by these amazing speakers, and they sent to us, and we're making them available to you at any time. So come back to jdconf.com after the event, and you will have access to all these sessions as well. The last thing I want to say, if you are joining this event today and you are one of the first 200 developers who checked in and are watching now live, and you are connected to a Microsoft account through the Microsoft Reactor website, you have just earned 5,000 points on the Microsoft Rewards program. What is the Microsoft Rewards program? It is a program that allows users, not just developers, but users. And you are a developer, you are a user of Microsoft technologies, potentially. You have access to those points, and then you can redeem them with any gift card from Microsoft Rewards partners. And you can also participate in sweepstakes and maybe have a chance to win even more amazing prizes. So the first 200 developers that are watching now JDConf live will get those 5,000 points. And then for the other 2 editions, the Asian edition and the EMEA edition, Europe, Middle East, and Africa edition, will also get 5,000 points, the first 200 of each of those time zones. So if you're watching now, but you were not one of the first 200, that's fine. You can try again. Remember, the content of each time zone is different. So if you are able to watch the other editions of JDConf, please do so, because it's not new content. It's different speakers. We're not just repeating content for different time zones. That's old school. It's a globalized world. So let's enjoy new content wherever you are. So now, let's go to the keynote. I had a chance to go to Microsoft Redmond office, the main office in near the Seattle area in Washington State of the United States. And by the way, it's a short drive from my house. I drive like 2 hours across the border, US and Canada, and I'm there at Microsoft office, and I can meet my manager and have a wonderful lunch. And you can do that as well. If you are in the area, you can just go and visit the Microsoft office. There's a nice store that you can buy some nice swag. I had a chance to go and record a message with Julia Liuson in our developer studio. So I'm wearing different clothes and just enjoy the recording. And then we're going to be back to the live stream with our first speaker, who will join me after the keynote. And then we're going to have a chat. So stay tuned, watch the keynote, and enjoy this session. Thank you. Good afternoon, good morning, and good evening to all Java developers around the world. It is my huge pleasure to welcome you to Microsoft JDConf 2024. I'm Bruno Borges, and I've been a Java developer for 24 years, and I've seen how things have evolved in the Java world. And it's been an exciting time spending 5 of those last years here at Microsoft. This is the 3rd time Microsoft is hosting JDConf, a Java developer conference that mixes community speakers, Microsoft engineers, and partners. It is an awesome privilege to be here connecting with all Java developers around the world. It's not just about giving us tools, it's about creating an environment where we can really shine, innovate, and even disrupt a few things. And today, we are taking it a step further by welcoming Java speakers to share their experiences, insights, and the latest innovation in AI. We've put together an exciting agenda with 20 sessions led by Java experts of different areas. JDConf runs across 3 time zones so that all developers at every corner of the world have a chance to learn. Whether you're looking to level up your skills or learn the latest trends, there is something here for you. Stay tuned and discover practical ways to apply on your projects right now. For Americas, Theresa Mammarella from IBM will share with us everything we need to know about Project Valhalla, an exciting project in OpenJDK that is set to revolutionize how the JVM handles objects in memory. For Europe, Liz Reyes from OpenTide will talk about LangChain4j, and Rory from Microsoft will cover Semantic Kernel for Java, 2 of the best Java libraries to integrate AI into your applications. And finally, for Asia, we have Josh Long from Broadcom to talk about beautiful Spring Boot 3 and how can Java developers build together the next generation of Spring applications. Of course, that is not all. We also have other speakers and presentations from other Microsoft teams and our partners like Red Hat, Azul Systems, Docker, and customers like Citibank. We are very excited to have all of you here with us at JDConf 2024. Here's some helpful resources to immerse yourself more in the Java community. Go to jdconf.com and see all the agenda of the conference throughout all the 3 time zones. Sign up for the Cloud Skills Challenge and climb on the leaderboard. We can't wait to hear your thoughts. Share your feedback with us on social media by using the hashtag JDConf. Now, I'm thrilled to invite Julia Liuson, President of Microsoft Developer Division and GitHub. Leading the Microsoft Developer Division, Julia has been involved with Microsoft's investments in becoming a Java powerhouse since the beginning of Microsoft Azure Cloud. Let's dive in and hear what Julia has to share about Java at Microsoft.
Thank you, Bruno. Hi, everyone. I'm Julia Liuson. I'm the president of Microsoft Developer Division and GitHub. We build the tools and infrastructure that powers every developer at Microsoft. I'm thrilled to be with you today to talk about how every Java developer can stay in the developer flow and focus on what matters the most, leveraging the power of Microsoft technology and AI. At Microsoft, our mission is to empower every person and every organization on the planet to achieve more. We have put developers first since day one. Our efforts have yielded some of the most loved coding solutions like Visual Studio and Visual Studio Code. With Visual Studio product family attracting over 38 million monthly active users. We have also established GitHub as the home to the world's largest developer community of over 100 million developers. And over 95% of the Fortune 500 customers trust Microsoft Azure for their business. As you can imagine, at Microsoft, we have a significant team of developers and IT professionals dedicated to creating cutting-edge solutions every day. Essentially, we serve as the first users of our own services ensuring they meet the high standards that our customers have come to expect from us. What's more, we're here to power up Java developers like you, making your coding life easier and more enjoyable. Our commitment to Java has been growing for more than a decade, sparked by the voices of developers back in 2008, calling for a Java engagement in our ecosystem. Today, it's amazing to see over 2.5 million Java developers harnessing the power of Visual Studio Code to bring their code to life. On GitHub, Java has consistently been a top language for the past decade, a true testament to its enduring popularity and versatility. And when it comes to Azure OpenAI, Java is right up there as one of the most used languages, leading the charge in cutting-edge AI development. We're thrilled to support the Java ecosystem, providing the tools and platforms that you need to innovate and succeed. We are not just supporting Java developers. We're running on Java too. Today, with over 2.5 million JVMs running Microsoft's production workload, Java is at the heart of many of Microsoft's key operations. For instance, since joining Microsoft family in 2016, LinkedIn has been leveraging Java at an epic scale, managing 5 trillion messages and 5 petabytes of data daily on its Apache Kafka clusters. On Minecraft realms, we have seen peaks of up to 100,000 VMs per day through Azure PlayFab service. Beyond LinkedIn and Minecraft, Microsoft's Bing search engine and Azure's infrastructure also uses Java extensively in a variety of different ways. And as you can see from the numbers on the slide, the volume is quite significant. To truly support Java developers, our efforts span 3 critical areas simultaneously: community, our product offerings in dev tools and services, and the broader partner and ecosystem. We are dedicated to enhancing your Java experience, and we're actively involved with key community organizations like the Java Community Process, the Eclipse Foundation, and the Apache Foundation, all to make Java even better. We have a specialized team focused on the Microsoft build of OpenJDK, ensuring it's optimized for the Java workload on Azure and tailored to meet a variety of different internal requirements, all while continuously improving and contributing improvements back to the OpenJDK project. We're truly thankful for the trust and collaboration extended by these community engagement and organizations. And now it's my pleasure to introduce Josh Long, a leading figure in the Spring community. He's here to share his ideas and enthusiasm for the Spring ecosystem. Welcome, Josh.
Hi, Spring fans. Look at us. We're all here together, a community. And there's never been a better time to be a Java and Spring developer. We live in an age of unparalleled access to amazing technology. Java 21 just dropped, offering virtual threads that provide hitherto unthinkable scale with next to no code changes. Graalvm native images give us lightning fast startup and lightweight RAM footprint. And of course, AI, the freaking singularity is here. So now, these days, you've got lightning fast Spring Boot applications that scale both down to 0 and up to hero, and you want to get it to production. Well, this couldn't be easier than with Microsoft Azure. And all of this is for the community and by the community. It's a virtuous cycle. Nowhere is that collaboration more evident than in the enduring alliance between Microsoft and Tanzu by Broadcom. We're doing really cool things together. The collaboration goes beyond just merging efforts in various strategic investments and product launches, like the introduction of Azure Spring Apps Enterprise, built together by Microsoft Azure and Tanzu by Broadcom. It also includes significant contributions to the Spring community. And what truly excites me is the commitment to continuous innovation. There's never been a better time to be a Java and Spring developer. We released Spring Boot 3.2 with support for all of the aforementioned things. And of course, I'll be talking about it here at JDConf, so I hope you'll join me for that. Spring Cloud for Azure, a joint effort between the Spring team and Microsoft, provides a really powerful toolbox to leverage all the amazing services provided on Microsoft Azure in the idioms familiar to a Spring Boot developer. And last year at Spring One, our own developer show, we introduced Spring AI. And in the same breath, we announced the Microsoft OpenAI Azure support for Spring AI with Microsoft on our keynote stage. AI is a huge deal. Most people don't need to develop their own models in the same way that most people don't need to develop their own SQL databases. They just need to know that they have a model that they can trust and with which they can integrate. There's a whole pipeline involved in connecting your data to an AI to inform the responses that you get from it. We call this RAG, or Retrieval Augmented Generation. And Spring AI helps you with all of that. And it does it in a way that's familiar to Spring Boot users with auto configuration and smart heuristics. The Java ecosystem is crushing it. There's never been a better time to be a Java and Spring developer. Building super fast, integrated, AI-ready, scalable applications and getting them to production has never been this easy. I hope you enjoy your journey to production with Spring, Cloud, and AI. Thank you, and happy coding, everyone.
Thank you, Josh. As you can see, we are fully committed to the success of the Java community. And we think a lot about how to make Java developers' life easier and make it faster for Java developers to build applications. We have many exciting new capabilities to show you in our DevTools, AI, and cloud product portfolios. From a tooling perspective, GitHub Copilot is a game changer in the developer tool space. Developers using GitHub Copilot have a much faster time in completing their tasks. Some research has shown up to 55% faster than developers who aren't using GitHub Copilot. We brought Java to Visual Studio Code, and we have Playwright for Java to easily test your web applications. Java is not just another language, it's a powerhouse in AI, renowned for its strength, versatility, and global reach. And AI is reshaping the way developers work. We're making huge investment to help support Java developers on their journey to AI, such as Azure OpenAI client libraries for Java, contributions to LangChain for Java and Spring AI, Java Intelligent Apps patents, and collaboration with our Java SDK team for semantic kernel. And when it comes to cloud, Azure has got your back with Azure Spring Apps, Container Apps, Azure Kubernetes Services, App Services, and more cloud services designed to meet you wherever you are in your cloud journey. GitHub Copilot has been a revolution for developer productivity, and that includes Java developers. I would love to recap our recent GitHub Copilot announcement in early March of this year, where we announced the general availability of JetBrains Chat, broadening Copilot Chat's reach to another IDE, IntelliJ. This milestone follows our successful GA releases for Visual Studio Code and Visual Studio last December. So let's talk about some of the key features that we have. Like GitHub Copilot Chat in Visual Studio and Visual Studio Code, GitHub Copilot Chat in JetBrains is fueled by GPT-4. This contextually aware tool provides real-time guidance within the IDE, enhancing developers' productivity by offering precise and relevant suggestions tailored to their specific coding scenarios. Another power of GitHub Copilot is your ability to ask questions in your preferred language. Developers can effortlessly communicate in their natural language, whether it's German, Portuguese, or something else. Copilot automatically adapts to the user's natural language input. And all of these capabilities really provides comprehensive coding assistance, whether it's discussing complex coding concepts, identifying security vulnerabilities, or creating unit tests. Copilot Chat empowers developers to innovate swiftly and efficiently. Java developers using IntelliJ can now supercharge their coding experiences with GitHub Copilot Chat. Copilot Chat, powered by GPT-4, offers real-time guidance, enabling developers to write high-quality Java code with ease. Okay, it's time to look at the demo.
GitHub Copilot is a mature and trusted AI pair programmer used by more than 1 million developers, and now it's available in IntelliJ and the latest suite of IDEs from JetBrains. It's fantastic at inspecting your code, including natural language comments, and predicting what you need next. And if it doesn't give you what you want first time, it'll work with you, ultimately making you more productive. And now with GitHub Copilot Chat, it truly feels like I'm working with a pair programmer. For example, I can ask general programming questions like, what are some best practices for storing passwords in Java? Copilot lets me know, and in this case, it even provided some sample code I could use. I have some password validation code already, but it's a regular expression, and those are not easy to interpret at a glance. In IntelliJ, I can now ask GitHub Copilot Chat to explain any code I'm unfamiliar with, even if it's a regular expression. Copilot Chat is also great for helping you with documentation. Using the /doc command, it will create comments explaining what my code does. And even better, I can even get help writing tests for the code I'm looking at. Copilot is smart enough to understand from the code and comments exactly what I'm looking to test and can help me implement them. It can even suggest tests that I might be missing. GitHub is the AI-powered platform that helps your teams write more secure, better documented and better tested code faster than ever before. The plugin is available now for everyone with GitHub Copilot. Install it from the JetBrains marketplace today.
We take our commitment to your success very seriously and have invested in the end-to-end cloud experiences for Java developers. Whether you're using Spring or any of the popular Java frameworks and application middleware, Azure supports them natively with tight integration into the rest of the platform and partner services. With Azure Spring Apps, you can implement any application architecture, from monoliths to containerized applications, all the way to completely microservice-based apps. We had partnered with Oracle, launching jointly developed solutions for Oracle WebLogic Server on Azure VMs and on Azure Kubernetes Service. And we have also collaborated with IBM for WebSphere Application Server, WebSphere Liberty, and Open Liberty on Azure. Red Hat JBoss EAP is another popular platform, and on Azure, we enable you to deploy your Java EE or Jakarta EE applications on Azure with integrated support from both companies. Last but not least, if you work on Tomcat, with Azure App Service, you can quickly build, deploy, and scale your Tomcat web applications on a fully managed Linux-based infrastructure. Besides the partnerships, we also provide seamless integration with your favorite Java framework and IDEs. For example, you can easily bring your Spring Boot application to Azure and can deploy your applications using Maven or plugins in your IDE, such as IntelliJ, Eclipse, or VS Code. Once your app is up and running, you can continuously integrate and deploy app updates, auto-scale your apps, while taking advantage of the full suite of Microsoft services, such as GitHub, the Microsoft Build of OpenJDK, VS Code, and Azure. We empower thousands of customers to run their business using Java. Over the years, we have helped Java customers in every industry to land on Azure. One such customer who runs their Java apps on Azure at a massive scale is Bosch. Bosch's story with Microsoft Azure really showcases a pioneering approach to Java-based supply chain efficiencies. Bosch's IoT team developed Track and Trace. It's a Java-based solution to enhance supply chain transparency and provides real-time goods location data. Track and Trace has moved to Azure, specifically Azure Spring Apps, a fully managed service for running Spring Boot applications. Switching to a managed platform freed Bosch engineers from infrastructure maintenance so they can really focus on what they do best and respond more quickly to customer needs. In addition, Azure provides end-to-end health metrics and insights that the Bosch team didn't have before, making it significantly easier to operate this powerful interconnected service. The Track and Trace system utilizes 15 microservices on Azure Spring Apps, which work seamlessly with their existing Spring Boot and Eclipse-driven framework and requires minimal adjustment. They follow the best practices in the landing zone accelerator references architecture to ensure the microservices can easily communicate with other resources within Azure. They use Azure Application Gateway to accept incoming traffic from the devices and check that requests are valid before routing them to Azure Spring Apps. The migration also included 250 gigabytes of relational on-prem data they moved into Azure SQL. This way, Bosch was able to migrate apps dependencies as fast as the apps. Bosch's customer, Power BI, delivers relevant information in the form of charts, dashboards, and reports. Leveraging Java on Azure, Bosch has propelled its digital transformation, optimized their supply chain efficiencies, and fostered innovation. I know developers love hands-on experiences. Next, let's welcome Mark to walk you through a brilliant demo where Java unlocks the power of AI for a retail e-bike fitness store.
Thank you, Julia. As developers, we created a variety of applications that drive the success of our organizations. The example I'll share today resembles many of those apps and uses a portfolio of services to deliver a great experience to our customers looking to buy a quality bicycle and accessories. To accomplish this task, we need proven tools and a robust, versatile platform. As a proof of concept, and maybe just to show off a little bit, we've built various component services using different languages and tool chains, even incorporating some Python, JavaScript, and .NET. Foundational to all of it is Azure Spring Apps, which supports all of these offerings. But of course, it truly shines with Java and Spring Boot and AI. Let's take a look. This is a high-level view of our application's architecture. All customer interactions begin with in transit the Spring Cloud Gateway, which acts as the point of entry, balances the load, and routes requests for optimal performance. The front end is a Node.js application that uses the combined backend services to provide a rich, responsive user experience. As noted earlier, the backend services are built using a variety of languages and tool chains, all deployed to Azure Spring Apps. Several Azure services support the apps, including Intra-ID authentication and authorization, Postgres for data storage, Azure Key Vault to securely store and supply secrets, plus best-in-class automation and monitoring solutions. The secret ingredient is an AI assistant built with Spring AI and Azure OpenAI that cheerfully answers our customers' questions and helps them purchase the products that will make them the happiest. Here is a behind-the-scenes look at our services that compose our application. And just as we expected, everything is running smoothly. Now let's take a quick tour of the Acme Fitness Store. Here we see a very stylish homepage showing a small selection of our inventory, a navigation menu, and more. Let's begin by logging into the application using Intra-ID, made simple and secure by the magic of Azure Active Directory. Next, let's take a closer look at these beautiful bicycles and accessories. Wow, there are so many choices. Let's ask our AI assistant for some help. I'm looking for an e-bike. We'll ask, which bikes are e-bikes? And we see we have some choices here. I kind of like the look of this one. So let's go ahead and click on the Agile EM 9X. Let's see, it's a high-performance e-bike designed for riders seeking speed and endurance. I like the sound of that. Let's ask a few questions, like what kind of battery? Because this is very important. We want to be able to get out some really cool trails and maybe have some help getting back after we've ridden those hard trails. So according to this, it's equipped with a high-capacity battery. It's a removable integrated battery, extended range compatible. It comes with a 625 watt-hour Power 2 battery. Now that's pretty good, right? But I would like to know if there's any way that, if we have a long day of riding, I wonder if there's any way to add, is there a way to add a battery? Because there's nothing worse than just running out of energy before you get home, right? And we find that, yes, there is. It's extended range compatible. We can add an additional high-capacity 500 watt-hour battery. So that actually is almost doubling our range. That's really nice. But now the other question that we really need to know, how fast does it go? The burning questions, right? According to this, it can go up to 28 miles per hour or 45 kilometers per hour. I'm sold already. So let's go ahead and add that to our cart. It sounds really good. Let's go take a look here. And of course, the only question that remains in my mind is how long will it take for my order to arrive? When can we get out and get riding? And according to our Fit Assist, it looks like 3 to 7 business days for free shipping. We can upgrade that if we want, but I think a week is fine, less than a week. We'll go with that. I'm sold. I'll finish that purchase in just a moment, but for now, it's time to wrap up. In our short time together, we've seen how AI is a force multiplier in developing and fielding our business-critical applications. Thanks to Java, Spring Boot, and GitHub Copilot for building, GitHub Actions and Azure Spring Apps for deploying, and Spring AI and Azure OpenAI for taking it to the next level, the future is now. And we're here to help you make the most of it. Welcome to JDConf.
Before we wrap up, I want to direct you to the Java on Azure page on the Microsoft Learn website. It's a great spot to boost your skills with some reading and interactive learning modules. Java developers, you're part of the biggest, most vibrant, diverse, and innovative developer community on the planet. We're rooting for your success. No matter where you are in your code to cloud adventure, we're here to support you every step of the way. Together, let's shape the future of Java. Thank you and happy coding.
All right, so you watched that keynote. Clearly, it was a session that I got from Microsoft Office with Julia. I got this nice jacket after the fact, otherwise I would have worn that. Hey, Theresa, how are you?
Hey, I'm doing great. How about you?
I'm doing fine. Thanks for joining us. Where are you based?
I am coming from Toronto, Canada.
Okay, so you got two Canadians. It was completely accidental that we had two Canadians at the beginning of this show. If there is any other Canadian watching us, please comment on the chat. I would love to know where you live exactly in Canada. Probably in the south of Canada. Statistically speaking, that's where most people live. So Theresa, did you have a chance to watch the keynote, this video before?
Yeah, I caught the end of it.
Anything that you felt like, wow, this is impressive? I did not know about that.
Well, I'm certainly excited about all the awesome features that GitHub has, and I've tried out a few and learned a few new ones as well that I'm looking forward to use. I use it every day for my job. So.
All right, cool. So your session is about Project Valhalla, and it's a kind of new thing in the OpenJDK project. What should people expect from this session?
Yep. So I will be, since it's a pretty short session, I won't be able to cover every detail of Project Valhalla because it is quite vast in the goals that it has for the JDK, but I'll at least be going over the value types and null restricted value types that are the more concrete JEPs that exist today that do have a lot of experimentation and are fairly concrete at this point. So if you know a little bit about how the JVM works, it will be helpful for you, but I will do my best to explain along the way. So hopefully everyone has a chance to learn something new.
Nice. So it's a nice introduction to Project Valhalla then, like understand value types and how that may impact applications and application performance as well, right? It should improve performance.
Exactly, yes.
All right, nice. Besides coding, what else you do back in Toronto, Canada?
Yeah, so I guess other than coding, when it comes to tech, I'm pretty involved with the Toronto Java user group. We're having a meetup tomorrow, in fact, and I love to do conference talks like this as well to share things that I'm working on or that I find interesting in tech. In fact, I'm heading to DevNexus in a couple weeks after this, so doing a similar talk. So I'm looking forward to continuing to share about that.
All right, so traveling all around the world and escaping the warm spring of Toronto, Canada.
Yes, exactly.
All right, so we're out of time. I'll let you take over the stage and have a good session. Talk to you later.
Perfect. Thank you. All right. Welcome everyone to my session, Cache Me If You Can, Speeding Up Your JVM with Project Valhalla. As I mentioned in the intro, I'll be discussing the details of OpenJDK's Project Valhalla and how it will be used to speed up the JVM when it is released. You'll get the most out of this talk if you have some familiarity with Java and the internals, but I'll do my best to explain along the way. And if you do have questions, one of my colleagues, Hong Shou, who is an advisory software engineer at IBM and is an expert on both JVMs and Project Valhalla, is there to help as well. Again, my name is Theresa Mammarella. I'm also a software engineer at IBM, and myself and Hong both work on the runtimes team specifically on Eclipse OpenJ9, and we've both been involved in Valhalla support for this project. All right, just to jump right in. So to give you some background on why this project is important and what it's trying to solve. So in the early days of Java, when the Java virtual machine was being designed, the cost of a memory fetch was comparable in magnitude to that of an arithmetic operation, such as addition. If you've been paying attention at all over the last 30 years to how hardware has evolved, you will know that that is very much not the case anymore. In fact, it can cost as much as 1,000 times the time it takes to do an arithmetic operation to do a memory fetch. This is quite a significant change and does have quite an impact on our software. So the reason this has all happened is because CPUs have been scaling with Moore's law, which is the principle that the speed and capability of a computer can be expected to double every 2 years. Memory performance has increased slightly through other means. In particular, the architecture has changed significantly over time to take advantage of caching. And caches take advantage of the trade-off between speed and size when it comes to fetching data in memory. So closest to the CPU, there will be a small amount of memory that can be used to access pieces of memory very quickly. Further down, there will be something slightly larger that's a little bit slower, and so on until you get to the drive. Now, there has been a significant amount of work done to improve the speed of Java over the years, and it is still a very fast language. So the situation is not as dire as this chart may lead you to believe, but there is more work that can be done here. So to give you an example of how the caching can really affect a program and why it's important to take advantage of cache locality, I have an example here to share. So on the left, we have a program that is not Java, it's C++. And on the right is a chart measuring how many times an increment to a portion of this array happens. So the outer loop is not being measured. That is just to repeat the program over and over again. And as you'll see in the top left corner, where increments per second is happening very often, the speed of this is actually limited by the CPU. And you'll see that as the size of the array gets bigger and bigger, that number of increments increase because the outer loop starts to have less significance on the program speed. All right, but you'll see soon that it takes a pretty dramatic drop. And what happens here is that in the first section, the array size fits within the smallest, fastest cache, typically referred to as the L1 or the level 1 cache. And once that array gets too big, there starts to be cache misses, and then it will take longer to fetch data, and the speed is then limited by that size of the L1 cache. You'll see over time the performance continues to drop as the array gets bigger and bigger, and as we need to have more and more cache misses. All right, so let's talk about what objects look like in the JVM and how that might affect what goes into memory. So Java is an object-oriented language. Objects are instances of a class, and they are related to each other from the stack by pointers. Pointers are really useful in that it lets us represent null very easily, for example. But if you want to access a deeply nested field or many fields, you need to dereference quite a few pointers. And eventually, in a large program, there will be many references in the heap. They make up a large part of the heap footprint in the JVM. And because we're using pointers, there is no guarantee that objects may be positioned near each other in memory. So accessing objects has the potential to be inefficient. That something that logically makes sense to be near each other may be in a completely different cache or in memory. And one reason for this is that there is a separation of concerns in the JDK. There are many different pieces that don't necessarily know each other, and they handle their own piece of a more complicated puzzle. For example, the garbage collector, which handles cleaning up memory and placing that memory illogically in a heap, doesn't actually know about all of these references for the most part. And so it can make it difficult to take advantage of the spatial locality in memory. Another thing to note about Java objects is that they have a small header that contains some important information that we'll get into next. And this can also increase the footprint on the heap, make it more likely that there will be more GC cycles happening, and make it more likely that all these objects cannot fit onto the cache. All right, so what information is in these headers? Well, one important piece of information is the identity of an object. In Java, every object is unique. If you've ever written any kind of Java program, you will likely have run into a problem at some point where you used an equals equals operator instead of a equals method. And this is a great example of some awareness that we need to have for identity, because that equals equals compares the ID of an object, compares whether or not it's the exact same object, and the equals generally will compare the values in an object. Identity is important because by having a unique object, it allows us to have mutable fields and be able to synchronize on these objects, which are very key features that are used very often in Java. In a Valhalla world, these traditional classes that are typically just known as classes are now called identity classes. But the question is here, do we really need identity all the time? And it depends on the situation. For example, if in my application, my business logic, I need to represent a person and compare groups of people, do I need to have unique objects for each person? It depends on what's being represented there. If I'm just talking about how many software engineers are in the room, maybe I don't. But if I'm talking about healthcare information, then having those objects be unique is probably pretty important. And what about things like currency? If I'm talking about dollar bills, most likely it's not that important to represent dollars as unique objects. Another example where you may not need identity is representing a point in space or a line. So you have 2 points, and usually it doesn't matter which point is which or the order of them, or there's no reason that these need to be unique. And so with Project Valhalla, the idea is that if we forego the identity of an object, it allows us to get rid of that object header information, and those pointer references and create less indirection and be able to flatten those types in memory. So basically representing this object more as a primitive than as a traditional Java object. So on the right, you'll see that these 4 pieces of data that make up the coordinates of a line can instead exist right next to each other in memory as integers. This provides a very flat layout, which is cache efficient, and a dense memory efficient layout without compromising the abstraction or the type safety that is valued in Java. So how can we represent this in the JVM? So the first JEP that has been introduced in Project Valhalla that is not targeted for a release at this time is JEP 401 value classes. And pretty simply, it is introducing a class without identity. And because that class doesn't have identity, there are a few very important restrictions to keep in mind with these types of classes that have to do with identity. So the first one is that classes and instant fields are implicitly final. We talked about previously that identity allows us to have mutable fields. And so without identity, these classes, these fields are going to be set in stone when initialized. Synchronization on these objects is also not allowed without identity. The == operator takes on a new meaning for a value class since there is no longer an identity to compare. So it will, with value classes, have the same behavior as .= method, at least when that by default, so comparing the values. The next thing to note about value classes is that they are nullable. And this will make more sense why I'm talking about this in a few minutes, but this is different than a primitive. Primitives always have some kind of default value, but for value classes, they are able to be nullable. They must also be accessed atomically, and this is basically to make that flattening that we talked about, flattening in memory, easier. The fourth property is that they may be flattened by the JVM. It's important to say that flattening, even though a user may declare a value class by putting the value operator in front of a class, as I've shown in the code example here, it's never guaranteed. And one of the biggest limiters is the size of the object, because the object needs to be accessed atomically. And it depends on the platform what size this is going to be, but the default policy is sometimes going to be as small as 32 bits. So the object needs to be very, very small. And in fact, in OpenJ9 implementation, we don't even flatten these types of default value classes just because it hasn't seemed to pay off a lot, because it is very rare to have a useful value object that's going to be that small. And to make matters worse, one of the big problems is that when representing null, so as I mentioned earlier, when we have pointers to objects, it's easy to represent null because you can just have a null pointer. But with flattened value objects, null must be represented. Typically, it's being done with an extra bit to represent it. And because of memory alignment issues, that can mean that 1 bit turns into 32, making that object quite a bit bigger than it needs to be. So to help shrink these value classes a bit, the second JEP, that's the Java enhancement proposal that's going into Project Valhalla, is null restricted value classes. So instead of having a nullable class that's a value class, we're making it even closer to the behavior of a primitive and making it so a value class cannot be null. But if it's not null, then what is it going to be? So if you have a primitive integer in Java, for example, and you don't give it any value, it always resolves to 0. So the same idea comes with null restricted value classes. They must always have some kind of default field values. And these have to be opted into through the Java language. At least that's the design at the moment. So in order to declare that a field is null restricted for a value class, it's needed to have this exclamation point in front of it. And in order for that to be valid, the value class must have an implicit constructor, and that indicates that there can be default values set if there's no other constructor that applies. And by restricting null for value classes, it makes it so that there is a higher chance that flattening can occur for objects. To give an even better chance to value objects to be flattened depending on the size, there's also a relaxation in the policy that value classes need to be accessed atomically. You may or may not know that primitives such as long and double, they are not accessed atomically. So it only makes sense that value classes can have this option as well. And so that can be opted into as well for a value class by implementing the loosely consistent value. And it means that if there is a race condition, and new class instances may accidentally be created and have intermixing field values. But if the developer is okay with that risk, they can opt in and tolerate non-atomic accesses, which can lead to having bigger flattened classes. All right, so that is a very quick introduction to the first two JEPs that are around value classes in Valhalla. I have a couple of takeaways for you to think about if you're interested or think that it may be valuable to your application in the future. So first of all, given what you know about value classes, thinking about when it might make sense to migrate a data carrier class to a value class. Records are maybe pretty good candidates as well. In the future, along with JEP 401, it's proposed that some core libraries will be considered to be value classes in future releases. Another set of them that has been in existence since Java 8 is there's a concept of value-based classes now in the JDK that have unofficially the same restrictions as value classes, but they're not yet enforced. So something to keep in mind when thinking about whether this may be something useful in the future. There are builds available to try out with Project Valhalla. This project is still in the experimentation phase, and right now there is a call out to get input from interested Java developers in the community. A great help would be to try out prototypes and share experiences. This project will be potentially a big benefit to applications that do a lot of numeric computation, linear algebra, and machine learning. And there is potential as well to have improvements in the JDK itself by migrating core libraries to value classes, and also with compiler optimizations that were more difficult before these types of classes existed. So I've included some links here. There are OpenJDK early access builds available. I would encourage you to read the release notes carefully, because there have been a lot of changes happening with value types over the years. It's also possible to build value type support with OpenG9. I've included instructions here as well. And that is all that I have for you today. And please send your questions in the chat, and I will do my best to answer them. Thank you.
All right. Thank you, Theresa. We do have a few questions here. They were answered by Hank Shao, but for I think it's good to repeat the question. We also have Daniel and Brian Benz here. They're our next speakers joining. So, hey, Daniel. Hey, Brian.
Hey, bro. How's it going?
How's it going?
Good. So, before we talk, let's give Theresa a chance to look into these questions here. One question was, Amir said, I have a question about GC types in Java. Aren't most of them marked compact collectors? I'm pretty sure they are supposed to preserve locality.
Yeah, that's a great question, Amir. So, yes, as I mentioned, that claim that GCs do not know anything about locality is not completely true in all cases, and every GC implementation is obviously a bit different, but that is kind of the theoretical separation, is that they don't know as much about classes as the JVM does.
Okay. And another question, where is it? Can value objects have references to plain old Java objects?
Yeah, great question. And yes, they can have references to Java objects.
Easy question, easy answer. Yes. All right. So, Brian, Daniel, are you guys familiar with Project Valhalla at all?
Something like that.
Yeah. Sorry, what you said, Daniel? There was a glitch.
Yeah. So yeah, I heard about it a lot. Valhalla, it's the Java 21, and then I gotta give it a try one time, like some few example, not deep dive. Yeah, that's what I got from there.
One last question here, Theresa. How value objects may perform on ARM CPU?
That is a great question. I don't have exact numbers about that, but yeah, might have to follow up on that one.
Yeah, my inexperienced CPU architecture person inside of me, who has never written a compiler at all, or a hotspot JVM, or any runtime, I will say somebody will have to write some code for ARM to do things.
Yes.
That's all. All right, cool. Brian, Daniel, what are you going to talk about?
Good question. So we're going to talk about OpenTelemetry, observation, Quarkus, Java stuff, as well as AKS, something like that. Yeah, pretty much fun stuff.
Okay, so do we imagine monitoring agents and things like that benefiting from Valhalla so they can consume less memory and impact less in the overhead of applications?
That'd be great.
That'd be great.
Not today, unfortunately. Yeah, we are looking at with Brian.
All right, cool. So, Theresa, any question to Daniel and Brian? They're going to talk about OpenTelemetry on Kubernetes, and what do you like to learn from them?
Wow, OpenTelemetry on Kubernetes, those are both the two biggest black hole topics out there. So I'm sure I will learn something, but I mean, anything new that I can learn about how to use OpenTelemetry effectively, I'm always on board for.
Yeah, okay. Fully agree with that. Black hole. You cannot escape once you put in the inside.
I'm going to show you some cool stuff with Copilot as well on actually generating some of this stuff without having to know much about it. As you point out, not a lot of people do. And so we got Copilot, which is like, it could be your expert sitting behind you and giving you pointers. We have Daniel as well, but
yeah, we can ask Copilot about the Valhalla and then OpenTelemetry integration stuff.
maybe Copilot was trained with the wrong data, and it will talk to you about Odin and God.
It will actually, yeah. It's going to go into Viking this and everything first. Then you have to tell it. You have to be very specific. That's the prompt engineering. That's why those prompt engineers get paid the big bucks.
All right, so let's make a quick cut. So, Theresa, thank you for your session.
Thank you for having me.
All right. So I guess we're jumping in. Welcome. Daniel, do you want to kick it off with some introductions?
Yeah, sure. Hello, everybody, and thanks for joining our session. And hopefully, you are keep enjoying the JDConf virtual event, one of the best one in the world. And then, so Brian and we are talking about empowering Quarkus application with AI, like a plus Gen AI, and then OpenTelemetry on top of the Kubernetes in the next 25 minutes. If we go into the next slide.
Yeah.
So my name is Daniel O. I'm working for Red Hat and then developer advocate and Java champion as well. So yeah, here's my Twitter handler, Daniel030. So you can ask me any kind of question, Java, JavaScript, and Quarkus Spring Boot, of course, and then a bunch of other things, serverless and GitOps and Kubernetes, something like that. Here's my friend, Brian.
Yep. Thank you, Daniel. So Brian Benz, cloud advocate at Microsoft. I've been there about 11 years now, working with Java and working with the cloud. And most recently, working with AI with Java in the cloud. So I've got some cool demos to show you. But yeah, you can find me on Twitter and all the socials, including GitHub at bbenz.
That's cool. And by the way, I'm based in Boston, and then pretty much Brian, West Coast side, right?
Las Vegas. I'm actually based in Las Vegas.
City.
Nice day here today.
All right. So yeah, the first part, I'm going to really talk about Quarkus and OpenTelemetry. I mean, for Java developer, you are pretty much interested in observability, like open tracing, open sensors. Now we have OpenTelemetry combined two projects, which is the second largest project in CNCF right after Kubernetes. So problem for developer, okay, how to enable OpenTelemetry to Java application using Quarkus? Next slide, please. So this is a common question for developers in terms of observability. So you got to hit this question. For example, what is the health of my application? You got some error, you got some exception, unexpectedly on your production, sometimes in local machine. Whenever you got to hit error, you got to find the root cause. You can go to like a Stack Overflow or Googling, or you can ask a Copilot. We're going to showcase that stuff today. And then more important thing, you got some performance issue, and sometimes that could impact your customer experience as well. So whole kind of stuff. This is a reason why you need to understand and then implement some stuff, your observability stuff. Next slide, please. And observability is technically combined three pillars, like a metric data, for example, Prometheus. You can have graphing some metric data, not only application, but also like a resources utilization, CPU, memory, or JVM, or some application, hidden memory, etc. And all kind of application logs, like from application side, not only Java, but also any kind of application platforms and frameworks. And tracing data, your application pretty much running on cloud, like a Kubernetes and a distributed architecture, which your application literally chain the application architecture. So you can keep tracing your application chain, and then you got some error, and you could literally find out which application you got some error. Like that's the reason why you have a circuit breaking or fault tolerance, avoid some cascading some errors. Next slide, please. So there are many observability tools, open source project to enable this kind of capability on your application. But today we're gonna focus on OpenTelemetry, which is the second largest one of already standard, de facto standard on observability area, like a landscape. So in order to use OpenTelemetry, your Java application, you need to specify your implementation using API or SDK. You can also instrument your data and collecting telemetry data like a metrics, logging, tracing, and the sending to or export to external services. It could be Jaeger, could be Jenkins, could be any infrastructure to put together and visualize that telemetry data. So go on next slide, and then here is the Quarkus actually provide extension. You can actually have on your Maven Java project as a dependency or Gradle project using module. So OpenTelemetry extension allows developer get telemetry data and send it back to your tracing infrastructure like a Jaeger server or something like that. So not only trace your RESTful API, but also you can actually trace JDBC transaction as well and visualize them. And a lot of people are actually asking me, hey, Dan, I got some issue because I already pretty much implement open tracing and then how to use OpenTelemetry. Luckily, we have a migration documentation and example from open tracing to OpenTelemetry tracing on Quarkus. So I'm going to hand it over back to Brian, talk about Azure AKS for deployment and measurement. Go for it, Brian.
Thank you, sir. So yeah, I'm going to talk a little bit about Kubernetes, how our managed Kubernetes and all that stuff works. But first, I'm going to show you the actual app that we built today as a demo. And it's basically, some folks might be familiar with this from 100 years ago. This is Minesweeper. We call it Microsweeper. And it's an interactive game, so you can click on it and play around. And this is running on AKS. Over here on the right, this is actually data that's stored in a Postgres database on Azure. Ooh, okay, so there's that one. And when I save this, it actually saves the results over here on the right in Postgres because it's really important to save that data. But it's a great little demo for keeping just showing people how this works. So behind the scenes, what we've got is let's see here. So we've got a couple of pods. Basically, all we've got is 2 pods that are running. This one is our app service. This one is our collector for open tracing, and they're both running right now. And what I'm going to do something a little bit bold. I'm going to share a link, and that link, everyone can play around with the app. So if you folks want to share the link, if you look at the comments, you should see a link there. There you go. Go ahead and play with the app. We want to get some telemetry data so everyone can go ahead and play with that app for a minute. I'm also going to do something, and I'll explain what I'm doing afterwards, which is, hang on, let's go back to there. I'm going to fire up a load testing run. So let's run this. And this basically runs 300 virtual users against the application itself. Oops. Okay. There it is. Rerun. There we are. And it's going to run 300 users. Let's just type whatever we want in here. And the test URL, blah, 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 rerun. There we go. So that's going to take a minute to spin up. And while that's spinning up, what I could do is explain to you what you've been looking at here. Let's zoom in here. So this is the Azure portal, portal.azure.com. I just fired up an Azure load testing instance. And the Kubernetes cluster that we're using is called Microsweeper Quarkus. That was created using the Azure portal. You can also use the Azure CLI. I've got a database for Postgres, and I've got a container registry. So those are the 4 components that we're actually using to build this. And the repo can be found at github.com, Benz, Microsweeper-Quarkus-JDConf. If you go to my GitHub repo at Benz, you'll find it there, and it's also forked from Red Hat, so you can grab that one. And go to the JDConf branch. So you want to go to the JDConf 24 branch. And Daniel has actually provided a really great overview of everything that I did to build this. But I'm going to show you a summary that I've got in VS Code that pretty much does the same thing. Before we do that, let's just check those pods, see if they're scaling up yet. Not yet. Okay. So it takes a minute for that job to spin up. But in the meantime, what I want to show you is what I did to run this application in Maven Quarkus Dev. You run that locally. After that, we're going to create the actual application. So what I did is create a resource group called Microsweeper Quarkus, created an Azure container registry called Microsweeper Quarkus without the dash. You can't have a dash because it's based on Docker Hub, and that's one of their limitations for names. And then create an AKS cluster called Microsweeper Quarkus, then a database, and we create a database called Score inside of there. We set a firewall and password, and then we have to set up a secret. So we actually set up a secret for Postgres. This is what the secret looks like. You just put your username and password in here, and then kubectl apply. You post that to the Kubernetes cluster, and once you've got that set up, you update the Kubernetes properties. So an interesting thing about Quarkus is you don't actually edit the Kubernetes deployment manifest directly. The Kubernetes manifest is actually generated from the application properties file and a couple of other things. So what you do is you customize the application properties file. Specifically, you update the database configurations, you update the container image, and you update the Kubernetes secret that I already mentioned there. So to do that, let's go in here. You can see here the customization for the Quarkus connection to the database. Actually, this is for the for the Postgres database and the database that you're actually using. Then you've got the username and password. This is an old one. This is the username and password that we use. It's passed from that environment variable that we just created with Kubernetes. And then we go into the AKS configuration. We set up the target is Kubernetes and a type is load balancer. And if we go down here, you specify the image, the container image that you're actually going to deploy to. And you basically, once you're done with that, set up the Postgres credentials and the secrets enabled. And then you do a Maven clean package, and that creates some Docker images. So we can go ahead and look at those Docker images. And in there, we've got one called Microsweeper Quarkus AKS. I already pre-created this in the interest of time. And this is the one you want to use. So you find this Docker image, and then you actually log into your container registry. You push it to the ACR. Let's go in and look at that. So if we go back over here, one of these is the container registry. There we go. And in there, if you go into repositories, I've got the repository here. It's already been pushed, and it's just sitting there ready to go. All right. So once that's done, we actually push that out to the repository. Now we can actually deploy this out to the Kubernetes cluster. And to do that, we use the customized generated Kubernetes that was created when you do the Maven clean package with the cluster itself. So for that, there's a key part here. I just grabbed the segment of the Kubernetes deployment manifest. Using the namespace, you choose that repository reference that I just showed you. And then anytime there's an update, it's going to deploy automatically. You use the container port 8080 and the service account name. So you just say kubectl apply and the target /Kubernetes/Kubernetes YAML. That's the one that was actually created by the Maven clean package generation. And you've got the app up and running. So that's basically what we're seeing there. Let's go back and check the pods now. Let's see what we got. It's still not scaling. Okay. It's not scaling anything yet. I don't know why. Anyway, should be seeing more pods here for the simplest collector. It usually scales a few more pods and a few more nodes as we go, but it's not doing it here. Okay, but that's all right. So that's basically in a nutshell how you actually get the code out to Kubernetes. Then we want to talk about OpenTelemetry. But let's go back over here to the slides for a second. So the way that managed Kubernetes works basically is that everything that you see here in this box, the API server, some data stores, schedulers, controller managers, cloud controllers are actually controlled by something called the managed control plane. So that automatically scales for you in AKS, which is very, very handy. It allows you to not have to worry about all of the management of the cluster itself, the healing, server monitoring, and things like that. And there's some cool monitoring stuff that you can use with OpenTelemetry and some other things as well, which are based on OpenTelemetry, which I'll show you in a little bit. Next up, streamlining the telemetry with GitHub Copilot. I did want to show you a little bit about that. So those of you, some of you might have noticed when I used Copilot there that there's a little thing on the right for Copilot chat. I'm going to show you how that works. So basically, GitHub Copilot is an amazing autocomplete. You can do all kinds of cool things. Just add some documentation and stuff like that. Everyone's familiar with autocomplete, but this is way, way beyond that. And then we have the newer feature, which is our Copilot chat. And that actually goes out to an OpenAI codex, which has scanned a ton of source code out there in the world and pretty much is an expert on any kind of application, source code, and YAML configurations, which I'm going to show you in a minute. So you ask a question, it understands context as well, and then it gives you back suggestions. And it works on Visual Studio, Visual Studio Code, NeoVim, and JetBrains IDEs, including all of the JetBrains IDEs, basically. And it just recently implemented for JetBrains the Copilot chat. Before that, it was just a standard Copilot. So check that out. If you've checked it out in the past, Copilot chat is now available in all JetBrains IDEs, including IntelliJ IDEA. All right. So for context, it keeps track of file names, any open files, where the cursor is, and anything you've selected in a file. And you can also use something called code spaces. So code spaces are a virtual implementation of Visual Studio Code. It runs in a container, but you don't need Visual Studio Code installed. So you can use it on any machine, including your phone. So let me show you a little bit about how this works. And this is a cool part of the demo, I think. So what I've got here is I've got a segment of a OpenTelemetry deployment. It's in OTel collector config YAML in the demos files that we have. And it's just a segment. It actually won't run by itself. So if I try to do kubectl apply file OTel collector config YAML, it's actually not going to run because it doesn't have enough information. So what I can do is I can go here, select it, and I do Control-Shift-I, and I go into Copilot and I say, how do I deploy this to Kubernetes? And this is the kind of fun thing because sometimes Copilot can be a little bit capricious. So basically it's using that reference and it's saying to deploy this OpenTelemetry configuration to Kubernetes, you would typically create a config map containing this configuration. Then the config map and the Kubernetes deployment then deploys to OpenTelemetry collector. So that's kind of cool. And here's an example of how you can create the config map. And then down here, it actually gives you the actual collector. So now what I could do is I can say, oh, that's cool. All right. So I didn't need to know how to do that. I don't know if anyone's ever tried to figure this out before. I find it very cool for something like if a file's just not working, you just paste the file in the Copilot chat and say, fix this. And it'll go, oh, yeah, you've got 4 spaces here and this is out of order, and it'll fix it for you. I can insert this into a new file, and I can go down here and I can create this one as well as a new file. So now I can close my Copilot and I've got 2 working YAML files that I can use to actually deploy this. I can deploy the config map and then I can deploy the OTel collector. And just from this segment, we have all the things we need to actually do this kubectl apply file, and it'll actually run. So that's kind of cool. I know I want to just keep things brief. So that's basically the demo I showed you, automated OpenTelemetry integration and deployment on AKS with Copilot. You get the idea. It's something you might be really, really good at OpenTelemetry, you might be good at Java, you might be good at Kubernetes, but all three of those, this is a very rare combination. And so Copilot just says, oh, yeah, I know what to do with this, and does the work for you, which is kind of
Yeah, just one thing I want to add, if you don't mind. So
Yeah.
Our demo one environment, Brian already installed OpenTelemetry operator on Kubernetes. So
Yeah.
in order to create the OpenTelemetry CR, you need to make sure install OpenTelemetry using like operator or helm chart on top of your Kubernetes.
Yes, there you go. So install the OpenTelemetry operator. That's what you do. First, you install a cert manager, and then you install the operator. And then you can deploy a simple config that's been created, and that's in that repo. Kube control apply, and this is the one here. And then I showed the config YAML and how to actually fix that YAML file. How would you deploy it to Kubernetes? So that worked.
Yeah, that's right. And you have to ask a very smart way some of the questions to Copilot.
Yeah.
If you're not, and then you got some wrong answer, and then you got to fail to create your OpenTelemetry stuff on your Kubernetes.
Absolutely, yeah. Prompt engineering. Once again, it's really, people dismiss it as, oh yeah, you're just talking to the computer. Well, that's what code does too, right? So you really, really need to understand the format that you get the best results from our Open AI. Now, and it can be capricious, by the way. Once in a while, it just gives you garbage. So will this stuff replace expertise? No, because sometimes it just generates complete garbage. You need to know enough about OpenTelemetry, AKS, and any kind of Java applications, including Quarkus, to know if what OpenAI is giving you back makes any sense. So.
Yeah, one good thing is for like developers, Java developers, so you can actually save your time during inaudible process with the Quarkus, because the Quarkus automatically generate Kubernetes manifest, and then you can externalize your sensitive information with this Kubernetes secret, which exactly Brian showcased just a bit earlier. So you could spend a little bit more time to figure out OpenTelemetry with the Copilot, and then with some documentation as well.
Yes, absolutely. And okay, so let's go into insights. So this is some of the practical instrumentation and implementations we have. You can see, I decided to refresh it. It's going to take a second. Let me go into some of the metrics while that's refreshing. This is actually an overall metrics page I wanted to show you, and it wasn't updating, so I refreshed it. Now it's taking its time. There we go. All right, so you can see we did the load testing, and look what happened. It started firing up. I'm going to make this a little smaller so you can see all the different things. So we got the node CPU virtual utilization. I guess for the 300 users, for the servers that we have there, it didn't need to add more nodes, so it just ran on the other node. For the folks out there watching, I hope you were able to use it. You shouldn't have noticed any degradation in performance or anything. If there was a degradation in performance, it's set up to auto scale. So, but it looks like our memory and our node count and everything's pretty solid. We also have some other metrics we can show you, like, okay, microsleeper Quarkus, select metric, in-flight requests. So basically, it's just been scaling nicely, and I can add a metric here. I can choose cluster health. There you go. It's pretty solid. I can add a metric for, let's see, nodes usage percentage. Let's add that. Oh, yeah, there you go. So that actually, this is the test I did last night. And this is the test for today. So you can see the percentage went up, but it never went over. Boy, it really didn't go over very high. So the highest we got here is for the CPUs is 2 or 3%. Wow. Okay. So we didn't really need to add any more nodes. So that's why it didn't scale up for us. We've also got some other, I can actually go in and look at the OpenTelemetry data that's being collected from that collector. If I go in here, I can go, let's go back to the main screen. All right. And let's go to controllers, and I can say OpenTelemetry. OpenTelemetry. And I made this a little bit smaller so we can see everything on the screen, but I'll zoom in a second. All right, let's look at the manager. And in here, I can just view this in Log Analytics. And from there, it creates an automatic query for me. And I can run that query. And here we go. So, we got some errors. All right. OpenTelemetry operator, container ID. Anyway, you get the idea. You can actually do a query. You can run data. You can find information here on your OpenTelemetry itself without doing any other kind of visualization. Of course, you can use, as Daniel mentioned, Zipkin and also Jaeger as well. But you can look at the data here too. And you can store all this data and save it as well. And you can share it and do all kinds of things based on the metrics that are built in here. All right. So I think that's basically wrapping up. We got 4 minutes left for questions. And yeah, we'll take some questions. And if anyone has any feedback, I hope you enjoyed. I hope you got to play with the actual app itself. And yeah.
Yeah. And just one thing I want to mention about that, you can also using Jaeger server as a backend for OpenTelemetry, like a more traditional way for developer standpoint. You can actually stand up Jaeger server on your local machine, grab some telemetry data, and then visualize that stuff. But today we're gonna more showcase advanced visualization based on Azure, like insight and metrics. Maybe it's not super familiar with the normal Java developer, but it's pretty much handy for like a DevOps engineer or even senior architect and developers as well.
Yeah. So I'm looking through the questions here. Yeah, paste the repo link. I can do that. Hang on a second here.
I already did that.
Okay, cool.
Yeah. So
Thank
if you have you can try out, and then you can have any question, issue, you can reach out to me and Brian directly, our Twitter handler, or you can create a pull request or issue, just like open source. Yeah, we are more than happy to handle that.
Absolutely, yeah. All right.
Alrighty. I don't think we
Anything to
have
add, Bruno?
a question anymore.
Sorry. I was looking at the chat to see if we have any questions, but I don't think we have. We don't have much, but I do appreciate you sharing the link to the repo so that people can see the demo by themselves. It was interesting to see when you gave the URL for people to try the app, the chat went silent. So it was like,
yeah, everybody actually
everybody
played the game for fun.
Thanks for pumping the engagement.
Right. Yeah.
By the way, I'm gonna take that link down right after the presentation.
Yeah. Maybe next time we're gonna prepare like a REPL. So like a first one, we're gonna give some prize.
No, but it was good. I mean, it was a very dense presentation, and it's nice to see lots of technologies coming together in a demo. And that's what developers have to do at the end of the day, right? They have to combine lots of technology to deliver something useful for their end users. So it's nice to see that.
I should say, so Daniel has a great README. I condensed this, as you say. I skipped over a lot of things like setting up AKS and the database and all that, but that's all in the great README that Daniel put together. So
yeah. Okay. No, nice. Mark, hi.
Hey, what's up?
How's it going? Good.
Yeah. Get to see some of my favorite people here. That's pretty awesome.
Hey, Mark.
You got any question for Daniel or Brian?
Yeah, them. Just those two. No, just just kidding.
No, do you have a question for
my favorite people? So that works.
Yeah, you, Daniel and Brian are on Mark's bookmark tab. Whoever still uses that thing. Mark, do you have any question for them?
No, as always, just great, and great to see you guys. I'd one of these days maybe we'll like get to meet up again in person and exchange big hugs. But for now, it's pretty cool just to see you and hear you. So
I think everyone here is going to be at DevNexus, right? So give a little plug for DevNexus.
Crossing fingers.
Yeah.
Probably. There's a quick question on the chat here about Brian Daniels' session. How can we create a project for Azure and the main configuration? So I assume just take a look at the repo that they shared for their demo, and you have all the configuration there on how to.
Yeah, absolutely. Yeah, I put the whole instruction in the README file, how to configure, how to deploy the application in OpenTelemetry and the Heckler server on AKS and local machine as well. Yeah.
Yeah. Hopefully one day we can just put a project out there on GitHub and click on the link, generate a README for me, and voila. Until then,
take Copilot. Copilot chat. Create this demo for me. Enter. That's it.
All right. Well, Brian and Daniel, thank you so much for your presentation. Let's make a cut.
Thanks, Brian. And thanks, Bruno. Yeah, see you later. Bye-bye.
Thanks, Daniel. All right, see you.
Oh, wow. So I have to actually raise up just a little bit to make sure everybody sees this. Microsoft loves Java developers. I think that should be obvious by now, but just in case, it never hurts to reiterate the point. So, so let's dive in. Welcome to this session on paving a painless path to production AI in your Java applications. My name is Mark Heckler. I'm Principal Cloud Advocate of Java and JVM languages at Microsoft. If you have any questions, I'm going to try really hard to save a few minutes at the end for Q&A. But if not, or if you think of something 10 minutes after the fact, which is usually what I do, by all means, reach out to me via email or via X. Wow, that's hard to say. Anyway, so let me advance this. There we go. Okay, a bit about me, very little bit about me. I am primarily a developer, an author, and a pilot. So an advocate. So everything else is super nice to add in, but basically it comes down to that. So with that, you didn't come to hear about me. You came to hear about this. I think it's useful to establish what this session is not before we dive into what this session is, so we kind of are on the same page. It's not meant to be exhaustive because, after all, we only have 30 minutes. Yikes. But we will be talking about various different things. We just can't go very deeply into it. It's basically a conversation starter. We have 30 minutes today, and we have potentially unlimited time after that. So let's make the best of it to kind of prime the conversation and then continue it after the fact. What this session is really intended to be is a fast-paced, selective introduction of key AI concepts, as well as a quick review of the tools at your disposal for building AI-enabled applications. So kind of here are the things you can build with, and here are the concepts, here are the things you can build with, and then let's get in and get our hands dirty with a live coding adventure to demonstrate those concepts using Spring Boot Java and Azure OpenAI. I do, at the bottom, point out that the concepts are portable, so if you're not using those tools, well, the first question would be why? But the second point I would make is that all the concepts really apply across the domain. It's just that I try to use best of breed. So that's, those are the big three in my mind. Anyway, so again, to kind of summarize the plan, we'll talk concepts. We'll see how those concepts translate into reality. We'll see it in action because that's really where it in my mind, catches traction. And then we'll continue the conversation after the fact. So very, very briefly, again, this isn't meant to be exhaustive, and I do tend to generalize when my time is very, very short. So this will be a fairly quick, high-level overview. If you want to discuss this more, again, please ping me later. So when you talk about AI, you typically talk about large language models. So inevitably, you hear things thrown around about models. Makes sense. Typically, we kind of break things or categorize things into models generate something. So models generate text, images, or audio. There is actually a generative AI for video now, but it's not really widely available. So Sora exists. It's beautiful, but it's not really something I'm going to be covering today because it's not widely available. Whereas these others are. They're pretty well established in AI time now. So they, as you might imagine or might note, I've mentioned generative. These are generative AI, and by that, it means that it generates an output of some kind. In fact, GPT stands for Generative Pre-trained Transformer, which means that the large language model is pre-trained. You don't have to provide a bunch of training to it to make it useful out of the gate. It transforms inputs, prompts, if you will, into responses, and it generates those responses and then provides those. And GPT, that's where we get the name Chat GPT. You'll often hear tokens and tokenization spoken of. And tokens are the most atomic level of of context for an AI. So in language, in natural human language, we think of words as being the most granular, the atomic level of context. And tokens roughly equate to a natural language word. It's not an exact match. Generally speaking, tokens are about 3/4 of a word, so it's a slightly greater atomicity, if you will. So if you have like 1,000-word document, it's roughly equates to about 1,330 some tokens. But that's how an AI understands, and I say you'll hear me anthropomorphizing a lot throughout this, but that's how an AI will make sense. You establish some context, relevant context for any particular topic. Embeddings you hear spoken of often, typically in the context of an embedded data, or excuse me, embeddings in a database. But embeddings are, again, kind of overgeneralizing here, but they're a way to draw similarities and dissimilarities and assess those so that you get better results from prompts going in and better results coming back out. So an embedding, let's say you had an animal, a body of knowledge about animals. So if you have a database about various animals, you're wanting to do a prompt, a query about a particular kind of animal to see what other animals are similar. So for instance, a house cat has 4 legs and other various attributes that are cataloged and weights assigned and calculated and then stored. So a house cat might be assessed for similarities with something else, and we might come back with a domesticated canine, a dog. And of course, they both have 4 legs and whatnot, and they're able to be housebroken and things of that nature. So a cat would have more in common, more similarities to perhaps a wild rhinoceros. So embeddings help the LLM to make sense of what, or the AI to make sense of what is more common and less common, more dissimilar. Retrieval augmented generation, very fancy term. We usually shorten it to RAG because we in tech love our TLAs, our 3-letter acronyms. But it kind of explains itself, even though it sounds very fancy. It's an augmented way to generate and retrieve results. So you augment it typically with your own data. Now, there are a couple different ways to do that primarily, but largely what I will talk about and show you here later on is stuffing the prompt, which means you provide additional context for your query so that it operates basically on your data or more specific data. So for instance, if you're working for an insurance company, you want to get some kind of draw some conclusions based on your policyholders, that would be much more specific, and you would augment your search rather than have it operate on the entire populace as a whole. So it allows you to get more specific and get more meaningful results potentially. And again, all of this is evolving because literally you can, like I do, sign up for nightly updates, nightly build, nightly releases. So literally from day to day, this can change. And if that's a little too fast for your taste, you can dial that back. But literally this stuff is moving very quickly and you can just stay as fast on that leading edge as you want. It makes for some exciting times. So very quickly, those concepts translate to reality via a couple different mechanisms. One is applications and 2 is APIs. And from a developer perspective, we're far more concerned with APIs, but it's not like we don't notice the other stuff, right? So in terms of applications, ChatGPT, Microsoft Copilot, and let's say GitHub Copilot they take text, they retrieve, they generate text. DALL-E generates images. You have various different API-based models for audio. As far as I know, there's no widely available audio application, consumer-grade app. Probably is out there somewhere, but it's not widely available. But all of these things typically are available via APIs. Occasionally we'll have an edge case, a model that isn't available via API, but most of the time we developers have access. And that's really what we're after because most use cases involve some kind of API access. And currently most use cases are textual. Doesn't mean they'll stay that way, doesn't mean they're all that way now. And certainly they will, those various different valuable use cases will evolve and expand. But right now, kind of the low-hanging fruit, not super fan of that term, but it's there for a reason, The low-hanging fruit is there for textual use cases because there are so many that we can apply AI to usefully and fairly quickly in the grand scheme of things. Useful abstractions do add significant value, though, because all of these models may have varying APIs. And as developers, we want to make the maximum use of our time. And in areas of commonality, to have useful abstractions makes us much more productive and generally happier. It makes our code more maintainable as well. So in terms of tools, let me start with VS Code. VS Code, Visual Studio Code, is a great cross-platform, multiple language supporting IDE available for a download. It has great Java and Spring Boot plugins, great AI plugins, as you might imagine. GitHub being a company, Microsoft company, and they produce great software, GitHub Copilot, which is available first on VS Code. If you want to check it out, go check it out at code.visualstudio.com. And within a couple of minutes, after the talk, by the way, and within a couple of minutes, you can be up and running with that. And of course, GitHub Copilot. That's also available for IntelliJ IDEA. Now, a lot of Java developers use IntelliJ. I use IntelliJ. I also use VS Code. Some folks use one or the other. Some folks are like me. We use them both and love them both. So whatever your tool of choice, you actually can use GitHub Copilot to great effect. And I like to break Copilot into 3 different modes. Kind of maybe, again, once overly simplifying, but it's kind of useful to categorize. So read my comments is the first one. I don't use it as much, but it's useful when I want to, which is you write a comment, let's say in a class file, and based on how well you define what you're after, Copilot will create a method for you, for instance. And I do want to say something about that because just as in conversation, the more specific you are, the better the understanding. So if I start a sentence by saying, I woke up hungry this morning, I have no food in the house, I really need to go to then obviously most of us would complete that sentence in our heads with the store, the supermarket, the corner market, or whatever. But even there's some variability, right? So if you provide a very non-specific comment, Copilot won't have as much to work on. And chances are, you've probably heard the term hallucination. Chances are there'll be more of a chance of hallucination just because there are fewer tokens there to process to anticipate what should come next. But if I fill out more, the fidelity goes up very, very quickly. So it's incumbent upon us to maximize communication, just as it always has been. Better inputs equal better outputs. You can also use what I call read my mind or code with me. And that's kind of the mode that I fall into most of the time, which is I start writing code. I'm kind of in the flow. And Copilot, again, if I start off with a method signature, it may get enough context from that to go ahead and provide a method in part or in full that will meet my needs or approximate it. And you'll see sometimes that does brilliantly, sometimes it does okay. And again, part of that is just how much specificity I provide going in. Copilot Chat, which allows you to open up a chat window. And you saw this in the keynote in one of the earlier demos prior to mine, which is that you can write up something like, create a use case for this particular class and test these 3 things. And by doing that, it's more conversational. Copilot will provide you a test case. You can drop that into a new file, paste it into your current file, and so on and so forth. So check it out, github.com/features/copilot for more. And then, of course, you'll need a place to deploy these apps. Azure has numerous different targets for deployment. And these are the 2 that I lean into the hardest. So of course, I'm going to talk about them. In fact, I know there'll be just no time to share them with 30 minutes. But of course, if you're developing Spring Boot applications, Azure Spring Apps is a great home for those. Azure Container Apps also is a great home, but it also just kind of accommodates any kind of containerized app. So if you're building containers with any language, check them out, and others. So let's code. I'm going to just switch over here to the Spring Initializer. Let's see, how much time do we have? Doing great. Okay, so 10, 12, 13 minutes, we're good. So I'm going to just take this from concept to creation. And that's how I think best. I see it in action. So I'm going to use Maven for the basic, the build system for the project, using Java for the language, 3.2.4, the current version of Spring Boot. I'm just going to change some of the coordinates here. So the hecklers.com for the group. We'll make this our JDConf AI demo. And I'm going to use the current LTS version of Java. You can go up to the the newer one, that just released 22, or the previous LTS for 17. But I'm going to go right down the middle here. We'll keep it nice and simple. I'm going to bring in Azure OpenAI and Spring Web to build a web API. And then we'll generate that. And we'll drop that out here on the desktop. And then I will go out and open that up. So we'll open that. And of course, it dropped it over on one of my other monitors. So I'll just work with where it is. It's fine. I just need to open the project. Well, I'll bring it over. Open the project. You know what? I'm actually just going to open this up right here. Look at that. So I'm going to open the project in VS Code. Again, whatever you want to use, that's perfectly fine. And that, for some reason, is, yeah, let me bring that over. Bump that up. We'll close that window out. And we will open the POM. And of course, it's indexing. Let's try that again. POM. It is just going to make me do this all by hand today. That's perfectly fine. Let me bump that up to make it a little more readable. We'll do that later. And of course, you see that we added in a couple of things. We have Java version 21, Spring AI version, which is the current in-progress version of 0.8.1. And of course, we have Spring Boot Starter Web and the Azure OpenAI Spring Boot Starter. And it's exactly as we expected to have. I will show the application properties. You're going to need to configure your application to have an endpoint for your model, the model type, the name, I should say, deployment name, things like that. You can put those in your application properties. It's not a good practice because in your embedding secrets in your app, I actually load those in the command line so I can pull those in. Spring Boot applications absorb command line properties, or excuse me, environment properties, as well as command line properties. But of course, in a production environment, you'd probably put them in something like Key Vault to hide those secrets. For now, it's fine. They're hidden, at least from view. The next thing I want to do is pull up the application. And you can see this is a standard Spring Boot application so far, but let's go ahead and fix that now. I'm going to add a class, call this AI controller, and I'm going to make this a REST controller. Whew, trying to type too quickly, I think. So I'm going to inject a Azure OpenAI chat client. There we go. We'll just call this cleverly enough client. And you can see that Copilot is trying to help me and says, hey, look, you've got this thing defined, but you're not injecting it. And of course, with Spring Boot, the preferred method of doing that is constructor injection. So it's offering that up to me. I'll happily accept. It's helping me along as I go. Now, it's offering something, and I'm not really sure why it's doing that. In this case, it has no context, so it's just taking a run at it in the dark. And of course, it's not what I want. So let's go ahead and just add, again, a bit more specificity. So I'm going to create a get mapping. And this isn't bad, right? So it's offering this up to me. It's saying, hey, we'll pass a string, we'll get a string. The actual method name is wrong, but I can change that. And this actually would work. It wouldn't do much. It just returns whatever the AI would return from Hello World. So let's get a little bit more into things. But this is a pretty basic good start. So I'm going to define a request parameter. And what I want to do is make this a default value, not of Hello World. I'm going to close that window so we can see a bit more because I've expanded the text. But I'm going to ask, what is the meaning of life? That's not bad. And we will return, and just prompt it or clean that up. We'll take the message. And this is the simplest way of going about a call to the AI. We're passing a string, we're getting a string back. Since we're rather close on time, please take my word for it. This does work, but we want to get into the more interesting use cases as we go. So I'm going to go ahead and go from there and change this to a chat response, because that's where you can start seeing the full response and what's behind, a little bit, a peek behind the curtain. So we're getting that message back, but in this case, since it needs to take a prompt, we can pass the same message to it, and it'll return a chat response. And that works. But again, we're going to go a little bit further than that. So I'm just going to go ahead and plow on through there, and we'll go for the gold here all at once. So it's suggesting, or it's assuming that I want to add another parameter, which is exactly what I want to do. So I'll add request param. I don't want the default value there. I just want to indicate whether it's required or not. And in this case, I want this to be an optional parameter. I do want this to be a string, but I want to provide a celebrity because this actually, we're going to make this a fun response. So what can we do with this? Well, I'm going to take this. I'm going to first create a var here, and we'll call this our prompt messages, because I'm going to expand on this. Rather than just pass a single message, I'm going to pass several messages. So new array list of type message. And yeah, that looks pretty good. Now we need to make sure we have our imports arranged properly, or at least configured properly. And now we have AI chat messages here. At least we have the potential for an array of them. First thing I'm going to do is just do a prompt messages.add. In fact, this is a great point to show you add the user's message. And we see that it creates that. At least, ooh, yeah, that's not quite right here. So let's see. That doesn't seem right. Yeah, it wasn't actually a new prompt, except it's not new prompt. It's actually new user message. I'm kind of getting ahead of myself and in my own head, but we can fix that. So we'll import user message. One thing I do want to point out that with regards to interacting with the AI, there are basically four kinds of messages. One is the user message that you're providing in your prompt, or primarily providing in your prompt. There are others, which I'm going to get to next. You have a system message, which is the way that you describe to the AI how it should respond. So it's kind of system direction, system level direction. Then you have an assistant message, which comes back from your AI assistant. There's a function message as well, but we won't get to that today, but it's there. So really, we want to create a user message and pass that. And of course, we can do that right here. So we'll just do a call prompt messages. And let's see. So new prompt and the prompt messages, because it can take a list of messages as well. So that's fine. However, what about that celebrity? So what I want to do now is just do if celebrity doesn't equal null. That's pretty good. It's trying. I mean, it's doing not a terrible job here, but I'm going to let's take this a bit further, right? So what I want to do here is just create a system message, because I mentioned system message. I feel compelled to use it now. So we're going to just use a new system prompt template. And we will pass in something that says you respond. We're providing guidance to our AI in the voice and the style. Let's do style. That's probably a little more accurate. Of and our celebrity. And then I want to add the create message method. Create message. And we'll take a map of celebrity and celebrity. We'll add that. So that looks actually pretty good. Prompt messages add. And of course we need to import map. And that should help dramatically. That seems happier. So if we have a celebrity that we're requesting a voice of, then we'll use that. We'll add that in. I'm actually going to do one more thing before I run this. Let's just go for broke, because again, time is fairly short. What I want to also do here is create private final list of message, and we'll call this a buffer equals, yep, that works. Again, thank you very much, Copilot. We'll import that, and that looks pretty good. So each time I ask a question, what I want to do is just add, let's see, so we want to add our prompt messages there. But before we do that, we want to add any buffered messages. That works. We'll just add all of those. And then once we get here, we won't just return this. We'll do a var response equals, and then we will add buffer dot add all. Actually, you know what? No, that's just the opposite of what I want to do. So prompt messages, add all, buffer, and then prompt messages add response.getMessage. Nope, that's not exactly right. Dot get result dot get output. And you see that's an assistant message, right? So actually, I want to move that. Oh, come on. Move this up. There we go. And of course, we'll take that out. We add everything from the buffer. We take our prompt messages and let's see. And then we buffer dot add response dot get result dot, there we go. And then, oops, need to return response. There we go. Okay, so that looks pretty good. Let's go ahead and run this. I'm going to go out to my my terminal window, and we'll just do a /maven w spring boot run. Boy, this is exciting. It's all in one here. Let's go ahead and open another window. Once we run this, we'll test it, and then we'll wrap up with slides, code repo, and Q&A, assuming this all works. Crossing fingers. What could possibly go wrong in a 10-minute live coding session? We'll find out. So that looks pretty good. It seems pretty happy. So let's go here to 8080, the basic question, which is what is the meaning of life? Of course, there shouldn't be any way that the AI can surmise that. Let me go back here. We see that the full chat response is returned as an AI language model. I don't have personal beliefs. That makes sense, right? So message equals tell us about, let's see, let's go a little more specific. How many planets are in our solar system? And we'll go back here, and we have no celebrity voice, but let's go ahead and add and celebrity equals Snoop Dogg. Why not? Okay, so oops, my bad. I misunderstood your request earlier. Let me try again. So check it out. I can't do a good impression of anybody. I can't even do an impression of myself, so I won't even try. But we have that. That doesn't look bad. So let's go back now and say, because again, we're buffering this. So tell me about the fourth. And if everything worked right, if I remembered everything, and yep, I got confused again. The fourth planet from the sun is Mars. So this is good. We have context. We're repeating. We're stuffing the prompt with all the assistant messages that are coming back, and we're maintaining that context. And the AI is stepping up because, again, we're giving better inputs. We're getting much better outputs. So with that, there's so much more to share. I just don't have the time. So we'll go back here, and we'll wrap up. If you want to know more, I actually have this code and more, and I'm adding more as I go because this is an evolving talk, right? Just like AI. But if you want to go to github.com/mkheck/production-AI, check it out. Again, if you want to reach out to me after the fact, there are my cords. And let's see if there are any questions in the couple minutes we have remaining.
Hey, Mark, we will skip questions. So we are just at time.
Oh, hey, Loiane's next. I'll gladly skip questions and let her take the floor. But if anybody has questions, reach out to me. I'm happy to answer them.
No, thanks, Mark. Appreciate it.
Hi,
we have, Loiane, hi.
Hey, everyone.
Thanks for joining us.
Thanks for having me.
Loiane, I don't think everybody knows where you live these days.
I'm currently based in Florida, Orlando area.
Okay. All right. So nice weather almost all the time.
Yep.
Nice to hear that. Mark, have you flew through Florida already?
No, I have not. But this sounds like a perfect excuse for us to meet up at Loiane's house. So just just throwing that out there to the universe. I don't know.
You're welcome to come here.
Okay, great. Well, we'll coordinate offline and we'll make plans.
Just fly over and park on her driveway. I'm sure
There
your
you go.
plane on the
Short takeoffs and landings. Yeah.
That would be awesome.
Well, Mark, thank you so much for your presentation.
Thanks so much for having me.
Loiane, so you're next. Enjoy.
Thank you.
Oh, and before you get started, everybody watching, we do have this survey about Microsoft JDConf, the content, the speakers, the platform, everything, and other questions about Microsoft products and services. So please visit the URL on the screen, aka.ms/JDConf/survey. And we have a code there, 21593, that you can hit to go to the specific event survey. So thank you very much. And Loiane, up to you.
Thank you, Bruno. Okay. So, hey, everyone. Thanks for taking the time to be here. I'll give you a little bit of context of why I chose this topic. We're going to be talking about Java and VS Code and, how you can use VS Code professionally to develop Java projects. I've been working in this industry with Java for the past 18 years. And throughout all these years, I have used a few different IDEs and editors. And as a technologist that I'm sure some of you will agree as well, we're always curious to try new things. And we never know if something or a tool is going to make us more productive if we don't try, right? So for the past 2 years, I have decided to fully embrace VS Code, give it a try, adopt as my sole IDE. I still like the other IDEs, don't get me wrong, but I decided to give VS Code a try and transform it into my tool for Java development. So we're going to go through a few items during the session. We're going to learn about basic extensions. We're going to learn about Spring support, vulnerabilities, code linting, testing, test coverage, which is usually a premium feature, Docker support, database support, and also microservices support. And before we get started, in case you like to have the exact same extensions that I'm going to show today, you can go ahead and install this extension pack that has the Microsoft extension pack for Java, along with the Spring extension pack and a few other extensions. And without any further ado, let's go directly to the code. So switching back here to VS Code. First of all, when you install all these extensions, you're going to get a really nice overview for Java if this is the first time that you're using Java and VS Code. You can go to the command palette, and if you don't know, you can go to View, Command Palette, or press Ctrl-Shift-P or Command-Shift-P. So let's go ahead and do that. Oops, seems that okay. So let's go ahead in the command palette, and here we can type for Java. So we can create a new Java project. We have many different support here, like many different frameworks, Maven, Gradle, Spring Boot, Quarkus, MicroProfile, JavaFX, Micronaut, and a few others. And you can also, let me open up again. You can also search by Java, and you can open this overview. This will show you everything that you can do. This will also recommend a few extensions that you can install apart from the ones that we have already installed. Key bindings, if you are used to shortcuts from other IDEs, you can also use it. And if you don't have Java, or if you like to update your Java runtime, you can also configure your Java runtime. For this project in particular, I'm using Java 21. Java 22 was just recently released. And if you like to, you can also download other versions of Java that are available. And again, we have many vendors available. There is no vendor lock-in in VS Code, and you are freely to use anything that you like. So let me go back to this project that I have. I have a very simple REST API. And by the way, I have used Copilot to generate most of this code for me, which was very helpful that Mark just showcased to us. So this is a very simple project, and I have my pom.xml with the Spring started. In order to create this project, what I did was go back to my view command palette. And of course, you can search by Spring and you get the Maven project. I'm still Maven, but if you prefer Gradle, you can go ahead and create with Gradle as well. A Maven project, you select your version. I have a package name. Notice that I already have my package name. I don't have like the default that you get from the start.spring.io. Then you have the default name for the demo. You can give any name that you like. And then let's see some packages. We'll definitely need web for a RESTful API, JPA as well, so we can access the database. You can use Postgres, you can use MySQL, Microsoft SQL Server, any database that you like. Let's see, Docker support. This is really nice, and maybe test containers as well, since this is really nice to have. Again, I can search for any dependencies that I have, and this is a very similar experience that you get by using start.spring.io. And you can press enter. It's going to select, a folder in your computer where it's going to create the project. Now, you notice that I already had a few items selected for me. And this is because in my settings, I have some defined default values. So this is Java 11. I probably have to update this, but I'm choosing Java over Kotlin. This is the default project name, the package. I like to use start.spring.io. I'm using jar files. So you can skip a few of the questions that you get in start.spring.io. And at the end, it's going to create the same source code that you would get at Spring at the Spring website. So once we have our project created, let's say that you forgot to add any dependencies. Usually what we do a Control-C, we copy a dependency, and then we paste it here and try to modify. But what I really like, because I always like to use the approach of start simple and then start adding complexity to my projects. So let's say if I would like to add Spring Security, which is a package that I don't have, you notice that I have this add Spring Boot starters. Other way that you can get this is by also right-clicking and then add starters. And there we go. We can remove anything that we don't need anymore. We can add new starters, and that will update the pom.xml. So that's really nice. I really like this feature. Because sometimes we have to go back to start.spring.io, create a new project, see exactly the dependencies and the files that it's going to create if you add a new dependency. And this just makes it really easier and more simple without having to leave VS Code. So we develop our project. Let's see, let's open the controller class. This is a very simple REST API that we have. We have a service layer as well. And then we have, the get, post, put, and delete mapping. So let's go ahead and say that I would like to start this project. As usual, we can open the application file where we have the main method. You'll notice that we have this run button right here. Another way to start the project is through this play button, where we can choose between run or debug the project. This button is available regardless of the file that you have open. And the other way, which is my preferred way, is through the dashboard. You'll notice here in the Spring dashboard, we have all the applications. In my case, I only have this application at the moment. We also have all the beans and the endpoints. And this is really useful, and I'll show you in a moment. Let's go ahead and start this application. Hopefully everything is going to work out. Might take a few seconds to bring up the application. And there you go. Notice that now everything is green. We can stop. We can restart the application. We also have this little toolbar right here on the top that you can move and also control your application. You have all the beans. And notice something that is really, really nice, especially if you have to do some debugging or if you're trying to learn an application, what the application is doing. The controller, we have the service that has been injected, and the injection has been done through the constructor. If we go to the service, let's open the service, you will see that the service has been injected in the controller. And now for this class, we have a repository and we also have a mapper because we have a few DTOs here. So this is really nice to learn what's the flow, what's being injected and where, and really, really helpful. Now, if we go back to the controller, you also notice that for all the endpoints, we get this link. So we can try to open the link. It actually opened my browser. Let me try it again. So this is going to open your browser. But if you go to the endpoint mappings, you also see all the endpoints. If you click on this globe icon, it's going to open a browser inside VS Code. This is really helpful. It works with a get mapping, but if we're trying to do like a post or a put or even a delete, this is not definitely going to work for us. So usually what we have to do, we're going to use something like Postman or a similar tool. But a really nice premium feature that I like is to be able to do the HTTP request directly from VS Code. So to do this, we use a extension called the REST client. So this will be the extension that will allow us to create an HTTP file. And once you have this HTTP file created, you can add all your tasks here. So I have a get, I have a post. You'll see that we have this link to send a request. If we click, we have the response. We can also try a post, and you'll see that it has been created, 201. And now we also get the response back. So this is really nice. You can commit this file to your repository, and everyone working on this project will also have this functionality available to them, as long as they have the extension installed. What is really nice is because, especially when you're working with microservices and you don't specify the port and you don't know what port the service is up, you can copy the address and you can use to create your HTTP file, and it makes it really easy. So the other thing, since we have tested our application by running, we cannot forget about tests, right? So for this application, I also have a few tests. When you install the Java extension package, you'll have a Java test runner. So if you go to your sidebar, you will see this kind of like a lab icon for testing. And I love this view. It makes it really easy to see all the test cases that you have and run all the tests. For this particular API, I have 31 tests. I probably wrote like 2 or 3 of these test cases. Everything else was generated by Copilot for me. And if you like to, you'll see this file icon. When you click, it takes you directly to the source code. So in case of any of your test cases fail, you can go back to the test case and review the code, or refactor your code, make it pass depending if you're using TDD or any other testing approach. You can run all the test cases for the file. So you'll see this check mark, check icon. You can right click, run, or debug. You can also run one particular test case. You'll see in the test results tab here in the bottom. So we have the logs and the results of our tests. This has passed. And also you'll see the history of all the test cases that you have run. So this is really helpful. But what I love is that I can go to the Test Explorer, click on this button, this play button, and run all the tests, and hopefully everything will pass. So for me, this is very satisfying to watch and see everything turning green as the tests get executed, and everything is working again. So this is really nice. So 31 test cases pass. Thank you. We can move on and we can continue modifying our application. Now, when we're talking about test cases, and this is another premium feature, I would like to know if, even though I have written like 30 test cases, I would like to know if I have a good test coverage, and if I have test coverage for the critical path that I have within my business logic. So how we can do that? This is also usually a premium feature. And I always forget about this, so I usually have it documented within my project. So there is this extension. So let me just put it here in case any of you would like to install, which is called Coverage Gutters. This is also free, of course. So when you install Coverage Gutters, you will see that at the bottom we'll have this watch. So when you click on watch, we don't have any coverage. This is because we need Jacoco and we have to execute this command. If you're like me, and in 30 minutes, I'm probably going to forget this command. That's why I like to have it in a file documented. But if you don't like to run any commands manually in the terminal, one of the things that you can do is VS Code allows us to create tasks. So again, we can open the command palette and you can type tasks. You can configure a task. So I have already configured a task. I have called it task coverage and specify the command that I would like to run. So again, we're going to go to the command palette. We'll go in task, run task, and we're going to run the task coverage. So this is behind the scenes. This is going to execute that command for me, and it's going to run the test again. It's also generate the task coverage. But when we're working with Jacoco, it's going to create a test report under the, the targets, the site right here. So we'll have a few files. And when that's done, you can open the file. That's very useful for CI/CD pipelines. But as a developer, I would like to see in my code without having to open any other file if I'm doing okay or not. So if now we open again for the watch, and we probably have to run this one more time. Let's open the task coverage. And we try to open, for example, the service class. Let's go to the service class. Let me zoom out a little bit so you can see here in the bottom that we have 89% of task coverage. That's not a bad number. And if you notice now, we get these little marks here on the sidebar near the code lines. This is green, means that we have a coverage. And if we keep scrolling down, this is yellow, means that I don't have test coverage for every single output here. And red, this is probably important. So I should probably add some test cases to cover these red lines because they are part of a very critical business path within my application. And you can run it again and until you have the desired coverage. And for those of you that are working full stack, so this is only a Java project. So if you are a full stack developer, one of the things that you can do, if you prefer to have two windows open at the same time, that is completely okay. But if you're like me and you like to have everything in a single window, I'm going to load another project. And this is a full stack project where I have both the Spring API, which is the one that I just showed you, along I also have an Angular project. And as you can see, if we check the sidebar, if we give it a minute, we will have the exactly same support that we get if we're just creating and working with a Java project. So it took a few seconds, which is that's fine. It's gonna scan the project again, and we'll be able to see our applications, the beans, and again, you can work with the full stack projects or multiple projects if you have, without having to leave VS Code. And there we go. We have the same application with the endpoints as well. We cannot speak about Spring Framework without touching the microservices topic, right? Spring Framework is very, very popular in microservices architecture. And I have one example for you as well. So let me quickly switch back to the microservices. So this is what actually sold me to use VS Code as my go-to tool for Java, especially when working with microservices, is if I need to create a new service, add a new service to my solution, all I have to do is access the Spring Initializer, create a new project. I don't need to do anything else. It's ready to go. It's ready to go, and I'm ready to use and encode my new microservice. So, and this is really, really nice to have. So I just loaded the project. Notice that I have a few problems here at the bottom. We can install extensions such as Sneak or check marks, SonarLint, check style, all these extensions that we're used to from other IDEs. And we can get also linting alerts in our application. So for example, this one is telling me that I'm using an old version of Spring. Let me fix that up real quick before we, so I just updated my POM. I'm going to click on yes, and there we go. Now that error is gone and my project is up to date. So we can keep up to date with all the vulnerabilities. One other thing, and let me quickly double check. Yes, I have Docker up and running. I always forgot to do that. So for this particular service, if we go back to the dashboard, we have all the services. I can start the services. So let's do that. I have my product server, but before I need to bring up my containers. So we have a Docker here, Docker Compose. This is another premium feature. We don't have an icon right here, but the way that we can do this is right-clicking and do a compose up. If you're like me and you always forget what's the command, or you can install the Docker extension. And again, you can do a compose start, and this is going to bring up all your images. So now that we have our images, we can also start our projects. I have test containers here, so I get 2 applications. Let me just run the main one. The discovery service is already part of my Docker image, so I don't have to start it. But as you can see, we can also bring up all the services. If I have multiple applications, we can bring up multiple applications at the same time. You get all the beans. You also get all the mappings. And to finalize here, if we have database, for this particular example of the microservice project, I have MongoDB and MySQL. And I can have an extension for MySQL. If you're using a different database like Microsoft SQL Server or Cosmos DB, Postgres, what have you, you can install the extension that you need for the database support. So for the MySQL, I have this particular e-commerce. I can see that we have this product service. By the way, this is running on top of Docker. I have my tables here, products. And what we can do, we can select the rows. We can open a notebook, have this the SQL prompt where I can execute any SQL query that I would like. And very similar, I have MongoDB as well, just so we know one relational database and one NoSQL database. So I'm going to open localhost. I have my inventory here for my inventory service. I can see the documents. And of course, we can see all the documents, and we can also open a playground in case we like to do anything else. So as you can see, you can tailor VS Code according to your needs. Brian and Daniel already showed about the Kubernetes support. If you're working with cloud, all the major cloud providers also have extensions that are available, and you don't actually need to leave VS Code to do anything that you will need to do as a Java developer, regardless of the level of project that you are working with. So with this, thank you so much. I really hope you give it a try. And if you need any help, you can also contact me in my social networks. I'll be happy to help. Thank you.
All right. Thanks, Loiane. Appreciate it. We are also joined by Simon Ritter. Hey, Simon, how are you? You just have to unmute yourself. That's the usual mantra of meetings, online stuff. I think everybody should have a t-shirt. Unmute yourself.
Yeah, I put myself on mute because I was, trying to be good, and then I forgot.
No worries. So yeah, Loiane talked about writing Java code and Visual Studio Code. Are you using Visual Studio Code, Simon?
Afraid I'm not. Do you know what I use? I use NetBeans.
You use NetBeans. Okay. I used to use NetBeans when I used to code in Apache struts.
Yes, I use NetBeans, although I do use IntelliJ as well, because you got to use IntelliJ sometimes.
Right.
But yeah, I'm still a diehard NetBeans user, and my colleague and friend Hirchen will be very happy to hear that.
Yep.
So sadly, yeah, I haven't tried Visual Studio yet.
Visual Studio Code.
Or at least
Studio.net, Simon.
At least I did try Visual Studio many years ago for Visual Studio C++ and C when I was doing some development.
Loiane, what other IDEs have you used throughout your career?
I think I've probably used pretty much all of them. So obviously NetBeans, I did try Eclipse briefly, didn't really like that, I'm afraid. And that's, no offense to Eclipse, but it just didn't kind of work for me. It was like, Emacs. Emacs, nothing wrong with it. James Gosling had a lot to do with it, but it doesn't work for me. I'm a VI man.
Were you
so
a macro developer of Emacs, like writing macros for everything?
No. Like I say, Emacs was not a one for me. It was a VI for me.
What about you, Loiane?
NetBeans, Eclipse, IntelliJ, this professionally, BlueJ.
Oh, yes.
That was a really old one. Yeah.
Yes, because there's BlueJ and there was Greenfoot as well, wasn't there?
Yeah.
Wow, that's going back away.
I will bring up a name that you may fear or maybe you loved. Actually, two names. One is JBuilder.
Wow.
Yeah, no, never did that one. But I did remember another one I used, Java Studio. Now that goes right back to the beginning of Java. Java Studio was written in Java. And so much like some of the other IDEs now, but this was back in the JDK 1.1, 1.2 days. Java Studio.
I used one called Oracle JDeveloper as well.
Oh,
back in 2006 to do EJB development. It was a good XML editor, so I cannot complain.
What about YAML?
Yeah, well, but it was a good IDE for all the Oracle frameworks back then. It was a great IDE. It just generates everything like Visual Studio is for .NET. JDeveloper was great for Oracle BC4J. So good times. But I'm glad that we have a much shorter breed of IDEs these days. It's mainly NetBeans, Visual Studio Code, IntelliJ, and Eclipse, right?
Yes.
For Java developers. Yes, people can adventure themselves on Vim and Emacs or Sublime or other stuff like that, like text editors. But yeah, let's not do that. If we want to be really productive, like Loiane was showing in Visual Studio Code, you gotta have to have those nice extensions and features, right? And last IDE I used was JEdit. The JEdit. If you haven't seen that, go look at it because it's basically Visual Studio Code.
No.
But it was implemented in Java. Loiane, what do you expect as future Copilot enhancements and improvements? What do you in Visual Studio Code? What would you like to see that isn't there yet?
I think we have a pretty good support, right? I mainly use the IntelliSense from Copilot. As I mentioned before, when I was writing the test cases, I usually have to write the first one, and then Copilot picks up the way that I like to get things done, and then already suggests the next ones for me, along with the code as well. So it's good that it learns your coding style and is able to recommend according to that. The chat option is really great. To tell you, if you ask how to explain things to you or where you can find the database configuration, especially if you're working a more complex workspace, with a Spring config and you have all the configurations in a separate project. That is really helpful. I noticed there is a new extension for voice support. So I'm curious to see how that's going to work. Without having to type what you need.
Eventually, we're going to get to that point, aren't we, where it just says, write me a Space Invaders game. And there it is.
Yeah. Yeah. Or fix this bug. Go. Do it.
That would be awesome.
Right?
It's when it comes down to fix your bug.
Yeah.
As in the ChatGPT, the Copilot.
Report it back. It works on my machine. The computer is not going to fly. And Simon, your talk is about improvements in startup in the JVM, right?
Yes.
And I mean, one thing that most Java IDEs lack a little bit is that performance. Opening the IDE takes a little bit of time. The Visual Studio Code Java support relies on a JVM behind the scenes, and that also has a startup time. Do you see those improvements being leveraged as part of the IDE experience?
I think so, ultimately, because I mean, as I'll talk about, this has always been an issue with Java applications, is because we compile into bytecodes, and then those bytecodes have to be converted at some point into native instructions. How that happens leads to a delay in terms of the optimum level of performance that you can get from your application. And so the more we can do to alleviate that problem, the better Java is going to be for all those types of things. And like you say, desktop applications, if we think about, IDEs, that's something where that's particularly acute in terms of its visibility.
Right on. So let's make a cut here. Loiane, thank you so much, and have a wonderful day.
Thank you.
Okay, does that mean I'm on? Guess it does. Right, so yes, welcome. Good morning, good afternoon, good evening, depending on where you are. My name is Simon Ritter. I'm the Deputy CTO at Azul, and the title of my presentation, as you can see, is Instant Coffee, How to Eliminate Java Performance Warmup. Well, we'll see if we can eliminate it. Certainly the idea will be to reduce it as much as possible. So what are we talking about here? The issue that we face with Java is that, unlike most traditional languages, if you look at like C or C++, they get compiled directly from source code into native instructions which you target at a particular platform, whether that's Intel, whether that's Windows, whether it's Linux, whether it's ARM, but it's a particular platform that you target. Now with Java, what we're dealing with is compiling into bytecodes, and those bytecodes can then run on any platform that supports a JVM. This is the whole idea of write once, run anywhere. But the problem we see is that performance-wise, we get this kind of graph. Excuse me. We get this kind of graph where the application will start up slowly in terms of the performance that you get from the application. And then it will gradually increase over time. And that increase is as we see more and more sections of code or methods being compiled into native code as the application runs. And the time it takes to do that, to get to that sort of steady state where we've got our optimum level of performance, is what we refer to as the application warm-up time. So the longer that takes, the longer it takes to get to our application performance level. And the other problem that we see with this is that if we run our application, what happens is we go through this graph and we have our warm-up time and we reach our optimum level of performance. If we then start running the application again, we see the same thing. So we have to go right back to the beginning and we have to say, right, let's start executing bytecodes, let's analyze it, let's find out where those methods that are being frequently used are, let's compile them into native instructions and then run them and so on. And then when you run the application again, you say the same thing. So every time you run your application, you're facing the same problem. There's no memory of what's happened before. Now, what we'd really like to happen is to run our application once and go through that warm-up phase and see where we get to our optimum level of performance. And then when we run it a second time, we start from exactly that same point. So we start with that optimum level of performance because we've seen everything that we had to do before. And then we get a nice, flat, high level of performance. And if we run it a third time, we get the same thing. So that's what we'd really like to see. But obviously, being able to do that is very complicated. And there are different approaches that we can take to how to solve that problem. So what we're going to do is we're going to talk through a number of different approaches to how we could resolve that issue. First of those is AOT, or ahead of time compilation. Now what we're saying here is let's take the same approach that we do with C and C++. Rather than compiling into bytecodes and then having that platform neutrality, write once, run anywhere, what we'll do is we'll say, right, we are going to target Windows on Intel, or we're going to target Linux on ARM, and we'll compile into instructions specifically for that platform. Then we've got a native application which we can just start up on there, and that will be good because we don't have to interpret any bytecodes. So that saves us all that time. We don't have to analyze where the hotspots are. We don't have to figure out which methods to compile. we don't have to do that compilation as the application is running. This is one of the other drawbacks that we see with having Warmup, is that not only are you having to wait for that code to be compiled to get the best possible performance from the code, but you're also having to use the resources of the machine that's running your application to do that compilation at the same time. So you're drawing on those resources and reducing the resources available to run your actual application. And that has a sort of double whammy effect on that. So what we would be able to do is start at full speed straight away. Everything is good, wonderful. Now, this is the approach that Graal Native Image takes. I'm sure lots of people have heard of Graal Native Image. Lots of people have tried it out. And it's the way that they have approached solving this problem, is to say, let's compile, generate a native executable so you can run that straight away. So that obviously solves our problem. So really, I'm 5 minutes into my presentation, everything is done. We don't need to talk about anything else. Just go off and use Graal Native Image. Well, there wouldn't be a rest of the presentation if that was the case. So not so fast. What do I mean by that? Well, there's two things. One, AOT, ahead of time compilation, is by its very definition static. It is not able to change. You compile your code before you start running it, which means all of that compilation happens before the application starts running. That's ahead of time. And the code is compiled before it's run, which means that you have no idea in terms of the compiler about what that code is actually going to do when it runs. So the compiler doesn't have any knowledge about what's going to happen when the code runs. And that can be very important, because if particular code paths are used, if particular ways of exercising the application are used, that can have a really big impact on how you would compile the code to get better optimizations. Now, there is a well understood technique called profile guided optimization. Been around really since the beginning of when compilers were actually developed, which is the idea that you compile your code without knowing anything about how it's going to run. So you generate your static compiled code and then you run it with a sample workload. When you run it with a sample workload, you then take profiling information about how that application is running, how the different methods are being used, how the different code paths are being used, and so on. And then you take that profiling information and you feed it back into the compiler and you recompile into native instructions, but with the idea that you now know something about what the code is going to do when it runs. However, the problem is that this only helps partially. Yes, you can get a representative sample of profiling information that will help, but of course, if your application changes what it's doing as it runs, then you're not going to see that because you compiled it in a static way again. Now, to give you an example of why this is important, we have what's called speculative optimizations. And this is one of the things which really delivers a very big improvement in performance. And some of the analysis that we've done at Azul shows that 50% of the performance improvements we get through JIT compilation are down to speculative optimizations. Speculative optimizations are all about saying, okay, we've seen how the code runs up until this point. Let's assume that the code will continue to work in the same way in the future, and we'll compile based on that assumption. Here's an example, and it uses what's called branch analysis. I've got a slightly contrived method, but you'll see why in a moment. So my method is compute magnitude, takes a value, and then I do a test to see if the value is greater than 9. If it is, I call another method called compute bias with that value to compute the bias. If the value is not greater than 9, I simply set the bias to be 1, and then I return the log base 10 of whatever bias is plus 99. What we can do as we profile the code as it's running is to count how many times we go through the true branch and how many times we go through the false branch of that if statement. When we come to compile this method with the JIT compiler, we can look at that and we can say, look, we have never been through the true branch of that if statement. Let's assume that we are never going to go through the true branch in the future. And we can change the code in our JIT compiler. We can actually alter the code to something which is easier to optimize. So we can say, right, still got compute magnitude, still passing in a value, still have to have a test to see if the value is greater than 9. We have a contract between the compiler and the source code, which we have to honor. So we say if the value is greater than 9, we call this thing called uncommon trap. Uncommon trap says, right, we made an assumption, turned out to be wrong, so we have to de-optimize. We have to throw away the code we compiled and we have to recompile based on a new assumption for this method. However, if we don't do that, because we know that we've set bias to be 1, so that's a fixed value, and we know that we're returning log base 10 of 1 plus 99, which is 100, we can eliminate that calculation. So we can simply say 100, and we know that log base 10 of a fixed value is going to return a fixed value as well, which in this case is 2. So we simply return 2 rather than going through all of that calculation, method call, returning the value and so on. Makes life a lot better. And that's just one example of the kind of thing that we can do with speculative optimizations. So if we go back to our graph and we look at what we get with JIT compiled code, we're going to see this kind of shape. So we go through the warm-up phase, we identify all of the things, compile our code. If we compare that to ahead of time compiled code, what we're typically going to see, I'm not going to say every case is the same, but what we're typically going to see is that AOT compiled code will start up faster. So we'll get instant on for our performance, but the level that we'll get it at in terms of the optimum level of performance is going to be lower than it is with JIT compiled code, typically. Reason being, we can use these speculative optimizations, do those at runtime based on what the code is actually doing and be able to adapt to it. Speculative optimizations can't be used in AOT compiled code easily. You have to have multiple code paths and it gets very, very complicated. So nobody does that. Even if you apply profile guided optimization to feed back in that profiling information, you still can't use all of the techniques that you have available in terms of those speculative optimizations. So yes, you can make some improvements, do better things, but you're still going to end up typically with a lower level of overall performance. When would you use AOT? There are definitely places where AOT, GraalVM make a lot of sense. Ephemeral microservices, the AWS Lambdas, the horribly named serverless computing. If you have a service which is going to start up very quickly, do something, and then stop, then using AOT makes a lot of sense because the startup time is, the warm-up time is far more important than the overall speed. If it's a very short-lived service, what you really want is very fast startup and you're not too worried about if it's only 80 or 90% of the performance you get on a long-term run. Second thing is that, garbage collection is usually a non-issue because you're only running for a short space of time, so you don't worry about the thing that you have there. The other time that you'll see that AOT can be very beneficial is if you've got very constrained resources. If you're in a 2 vCore container, what you're going to see at the beginning is that your JIT compilation will be using one of those vCores to do compilation, which will then mean you've only got one vCore to run your application code. That's going to reduce your throughput by 50% while you're doing warm-up, and that can be, a big problem. So let's have a look at a different solution. Solution 2, what about if we store the JIT compilation data? Well, this is something that we've done at Azul, and we have our Prime JVM, and in conjunction with that, we have a thing called Ready Now. What this does is we say, right, run your application until it's warmed up. What we then do is we say, let's take a profile of the JIT compilation information. And that will consist of 5 specific pieces of information. So all the currently loaded classes, all the currently initialized classes, because that could be a subset of loaded classes, all the JIT profiling data that was collected up to this point and was used to then compile methods. Very importantly, we also need to know which speculative optimizations were bad. So we had to de-optimize because de-optimizations what we really want to avoid. If you're de-optimizing, you're throwing away compiled code and you have to recompile it. So it's a double hit in terms of that resource utilization. And then we also keep a copy of the compiled code so that we can potentially reuse that again. When you restart your application, what our JVM will do is it will say, right, we know what classes were loaded at this point. We know what classes were initialized. So let's load all those classes, initialize all those classes. Then we know all the methods that were compiled at this point, so we don't have to look at figuring out which methods during warm-up. We say, right, we know which ones to compile. Then if we've got code for those that we can reuse from our cache, we'll do that. If not, we'll compile those methods directly before we start running the application. So before you get to the main entry point, all of the necessary methods will be compiled and optimized based on that. So that will give you the point where when you start your main application, you get about 98% of the performance that you had when you took the profile. You need a couple transactions just to get it to 100%. There are a few things we can't do before the main entry point, but really 98% or thereabouts of that performance. So if we simplify our warm-up graph, without ready now, we see that gradual warm-up, optimized level. If we look at the same thing with ready now, what we'll see is a different profile. So now we're getting closer to that AOT kind of graph where we've got instant on. Much steeper graph in terms of that warm-up because there's work going on to make sure everything's compiled, and then much quicker in terms of delivering that full level of performance. However, the observant amongst you will see that there is a little bit of a downside, which is that there's a small period of time here where nothing is happening. So no application work is actually happening at that point. That's because we do all this work before we get to the main entry point, which means that class loading, initialization, compiling, and so on is being done, and that's before you can start processing transactions. So where this makes a lot of sense is if you are not too worried about immediate startup. If you're running something like a trading application, you know you want full performance at 9 o'clock in the morning, then you start your application at 5 to 9, has time to go through all of this, and then everything's ready at 9 o'clock with that level of performance. Solution number 3, what about if we decouple the JIT compiler from the JVM? So here's the thing about JIT compilation. It has cost. We've already kind of explained that. CPU intensive operation. You have to do all that compilation using the same CPU resources that you're using to run your application. The other thing is that the more you try to optimize, the more resources you're going to need to do that. If you want to generate more heavily optimized code, you're going to need more resources in terms of CPU and memory to generate that heavily optimized code. That works great if you've got a nice big meaty machine. If you've got 64 vCores, 64 gigs of RAM, you're probably not going to notice too much if 1 or 2 of those vCores are being used to compile your code, and you've got maybe 2 or 4 gigabytes of RAM being used for that compilation as well. But again, going back to the sort of 2 vCore container, 2 gigabytes of RAM, that's going to have a real significant impact in terms of degrading the throughput, because you've got 50% of your resources being used for compilation and only 50% of the resources used for the transactions. And you can even result in out of memory errors because you've got not enough memory to do the compilation and run your application at the same time. So we tend to end up with a bit of a compromise for that. And if we look at a graph of both speed and CPU utilization, this is running a simple application on a 2 vCore container. What we're seeing here with Hotspot is a sort of startup where we see the warm-up phase there. It's quite sort of short at the beginning, and then we've got a nice flat graph with the steady throughput that we need. But we'll see that on the bottom graph, which shows CPU utilization, that at the beginning, for the first part there, we've got a very high utilization, and then it drops down, and we've got nice steady state. So in this case, you might find that you have to provision 2 vCores in order to get that compilation done. But once that compilation is completed, you could probably get away with 1 vCore to run the application code. Now, what we've done as all is to change the way the JIT compiler works. The idea behind this is to deliver more heavily optimized code. And if we look at the same application running on the same hardware, but using our version of the JIT compiler, which we call Falcon, we see a different profile for that graph. If we look at the right-hand side of the graph, everything is really good. The blue line is higher than the orange line. That means we're getting more transactions per second processed. We've got more carrying capacity, maybe sort of 15-20% in that particular example. And on the CPU utilization, we can see that it's the same. So the right-hand side of the graph shows an advantage. However, if we look at the left-hand side of the graph, we can see that that's not without a cost. Firstly, the blue graph takes a lot longer to get to that heavily optimized level and the higher level of performance. And we can see several dips along the way, even when we've got to the sort of stable-ish level of performance. We can see dips in performance. And that's because of those de-optimizations. We're more aggressively using speculative optimizations, and sometimes we have to back them out and use other ones. And again, from the performance on the CPU, we can see much heavier usage of the CPU. That's going to reduce throughput for a lot longer. So what we said was, right, okay, let's decouple the JIT compiler. We're running in the cloud. Let's take advantage of that. Let's take the JIT compiler out of each of those JVMs running different services and put it as a centralized service, the JIT as a service, if you like. That way, all the different compilers or the different JVMs can then use that resource and not have to do it locally. Again, if we go back to our graph and we say, right, so we've seen the orange graph, which is our OpenJDK hotspot. We've seen the blue graph, which is our prime JVM with the more heavily optimizing JIT compiler. What about if we decouple the JIT compiler, put it as a service, and show the same results? Well, now we've got the best of both worlds. And in fact, we've even got better than the best of both worlds. If I drop the blue graph out just to show you the green and the orange together, you can see that the green graph has the same very quick startup. Okay, it takes a little bit longer to get to that optimum level, but it's much better than when we had the blue one. And really importantly, if you look at the bottom line, you can see that the CPU utilization drops off almost immediately. So once we've done that class loading and initialization and so on, we could really say to ourselves, yeah, we could probably get away with one vCore rather than 2 vCores to run this particular service. So that has a real benefit there. Obviously, some people will say, well, hang on, aren't you just shifting the cost? You're moving it from the individual JVMs and making it then a centralized service. But there are some efficiencies that we can take advantage of there. A couple of things are, one, we can say, well, let's put more resources there so we can do even more in-depth optimizations. And we can do that in the background. So when we come up with a more performing optimization, we can then proactively send that to a JVM that's still running that code. The next time a JVM starts up with the same piece of code, same method, then we can deliver that one to it. And we can cache everything locally in that centralized service. And that gives us that memory across runs of an application. Now we're getting much more to that idea of when you run your application once, it learns. Then when you run the application a second time, we don't have to go back to the beginning. We can take advantage of the fact we've already compiled those methods. We know what the code is, deliver it straight away. Final solution is, why don't we save the whole application state? And so if we look at Linux, Linux has a thing called CRYU, Coordinated Resume in User Space. And the idea here is really just like when you close the lid on your laptop. And you say, okay, well, I've frozen everything on my laptop. When I open it up again, everything starts up from the same place. Why don't we do the same thing for applications running on Linux? And so what this does is essentially take the program counter, takes the stack, takes your registers, all of the information about what's running on that application, freezes it in a user level file, and then you can restart it from the same point later on. So what we've done is to take that, and we call it Coordinated Restore at Checkpoint, or CRAC. So now we can have our Java application running, and we can say, right, at some point we want to take a snapshot of that, but the application needs to be aware that it is being checkpointed. That's really the key thing here, is the coordination. So it knows that something is happening. We're going to take a snapshot, and then we'll wait until sometime later, and then we want to start the application running again, rather than simply restoring all that state exactly as it was. We'll make the application aware that it's being restored. That gives us a number of advantages. So when you use CRYU, you can keep files open, you can have sockets and network connections and so on. We enforce the fact that you can't do that. So this idea of being aware that you're going to be checkpointed means you can close file descriptors, you can close network connections. You can even do things like taking a checksum on a file, so that when you get restored and you have to reopen that file, you can do another checksum and see, has that file changed since the snapshot was taken? And if it was, we need to reprocess the data in it and so on. So there's all that flexibility available to you if you want to do that. How we use that in terms of making the application aware is very simple. You have, for all of the classes that need to be aware that you're going through a checkpoint, is to have an interface implemented. So you implement the resource interface, 2 methods, before checkpoint, after restore. Obviously, that exactly what's going to happen. So the before checkpoint will be called when a checkpoint happens, after restore will be called when a restore happens. Having implemented that interface, you simply, when you create an instance of that class as an object, you then register it with the context for crack. You do that through the global context, or you can create your own context if you want. Then the JVM will know when a checkpoint is created, all the different classes where it needs to call the before checkpoint method. And then it also knows after restore where those methods need to be called as well. Does it work? Well, yes. So we've done a proof of concept here, and we looked at some simple sample applications. If we take a Spring Boot application and we say, okay, let's time how long it takes to get to first transaction. In the case of what we did here, it was the Spring Boot sample application, took about 4 seconds. By taking a snapshot and then restoring it, 38 milliseconds. So that goes from, that's 2 orders of magnitude faster. Very similar with Micronaut, took 1 second to get to first transaction, 46 milliseconds to get to first transaction with a checkpoint. Same with Quarkus, about a second, 33 milliseconds. So you can see that the reality of being able to do this gives you very, very fast startup. Clearly, you've got to store that state. So if you've got a very large heap, that heap needs to be stored somewhere, and various things like that. And we're looking at ways to improve that. So just to summarize, solving the JVM warm-up problem. I think it's fair to say that no one solution will fit all situations. Different needs for solving that problem will be solved by different approaches. AOT, GraalVM, very good for fast startup, small footprint, where you're doing ephemeral services, things like that. So it's a good way of doing things. Longer running services where you're more concerned with the overall level of performance, then you might want to look at different approaches like ReadyNow, where you're saving the JIT compilation data across runs. You can have cloud native compiler where you decouple the JIT compiler so you're not placing the load of the application compilation on the application as it runs, so you reduce that, and you can cache information and even apply heavier optimizations over longer time. And then, like I say, crack, which is where you're restarting from a known point by saving the whole state of the running application. There is another project in OpenJDK called Project Liuson, which is also looking at a same sort of idea, and they're exploring some different ways of sort of taking a somewhat ahead of time compilation, but not necessarily a complete ahead of time compilation approach. And it'd be interesting to see how that develops over time. And so that is that. I think I have a couple of minutes left. So if anybody has any questions, I may have time for those.
Right on time, Simon. Thank you so much. We continue to ask people to sign up for the survey. So go to ak.ms/jdconf/survey, and the event code is 21593. Let's get Simon back on stage. I got a few questions about Project Liuson and Crack. I was looking at our team at Microsoft was thinking about Liuson and Crack and other solutions, and you're right. I mean, there's no one size fits all solution. And the other thing that people forget is that even if one version of JDK has one of these solutions implemented, it does not mean that older versions will get those features, and does not mean that future versions will get all those features. So, okay, maybe for JDK 23, 25, we will get Project Liuson, but maybe for Java 21, 22, we need Crack.
Yes.
So there's a lot of trade-offs and balancing resources on where do we invest and which version do we invest, and then customers will have to decide, okay, which version of Java I'm going to invest on as I think about upgrading to the next release. Mm-hmm. So it's actually exciting to see a lot of projects tackling the core of the problem, and seeing different solutions, different implementations can help everyone understand where the bottleneck is. And maybe the bottleneck is the hardware. We've seen solutions where people just use a memory disk to put all the JVM files in it. Sure, It loads super fast, So there's a lot of creative ways to solve this, and it's really good to see Azul Systems and the team behind Azul to be investing in this area. So thank you for sharing that. Mark, welcome on stage.
Hello.
So, Mark, it seems like you are on a very odd time zone for this event. Where are you?
Oh, well, not really. I happen to be in the Dominican Republic right now. I'm hoping to start my vacation right after my talk.
Oh, nice. I just came back from vacation. You're doing the other way around. Well done. I hope you enjoy it.
Yeah.
So, Mark, are you familiar with any of these JVM startup improvement projects? Are you excited about them?
Yeah, I am very excited about Crack, because, I don't know all the details that he went through, but just for me as somewhat casual person, it's very interesting because it's much easier than native compilation, right? And it doesn't solve everything like native compilation does, but this one area is great. I mean, look at that graph at the end, right? Everything goes down to just under 40 milliseconds. So all these frameworks competing for the fastest startup time basically are out of business competing over this metric anymore. It's all the same. Anything under 100 milliseconds is not noticeable to a human being.
There was this 1 billion row challenge. 1 billion rows challenge.
Oh yeah, I heard about this. These artificial,
Yeah, and I think the top winner is a GraalVM AOT solution, right?
Yeah, that's at runtime. Yeah, right. To solve 1 billion rows. Yeah.
Yeah, it goes to show how fast it can be.
Lots
how
of innovation.
practical that implementation is in the business world, I'm not sure.
Well, yeah, benchmarks are benchmarks, but there's real progress here, right? And it means less energy, right, being consumed by these apps, and it goes faster. So it's a great win-win all around. It's very exciting to see this innovation in the JVM space.
Awesome. So Simon, Mark will talk about Java Enterprise and AI development with Spring. Anything in particular you would like to ask him to cover? How can Spring be faster with Crack and AOT and GraalVM and everything?
It'd be interesting to see how AI can be applied to that.
Yeah, we had this crazy idea of like, what if we asked ChatGPT to get Java bytecode and just optimize it? It's like, let's make it faster.
It's not all-knowing yet.
Awesome. All right. So Simon, thank you so much for your presentation. Have a good day.
Thank you very much.
Okay. Welcome, everyone. Thank you for coming to my presentation. Today, we'll be talking about Spring AI. It's a new project that will help you build AI applications and hopefully easily deploy them onto platforms such as Azure. So one way to motivate the conversation is, why do we think software developers can and should be developing AI applications? And it really comes down to a lot of advancements that we've had in the AI stack, right? That's been growing since the 60s. And here's an example of a data scientist. His name is Daniel Witnack. He hosts a very popular podcast called Practical AI. And he's been in this business for a while. He's a prominent speaker as well. And here are some quotes from an interview with him. He says, well, I go to a customer, they ask me to solve a problem. And the first thing I typically did was gather data and train a model. But this is changing right now with pre-trained models. I can solve a lot of these problems, and I can skip that step of me actually training a model. And as a result, what you see is he's now doing more of traditional software engineering, which are things that us as Java developers are quite accustomed to, and less around specific machine learning technologies that do take, in fact, quite a lot of expertise and time to learn. So the P in GPT is pre-trained, right? And that's a huge advancement. And the other advancement that I think OpenAI made is they made a very easy, public accessible API that you could access from any programming language. So that really was a game changer. And that is what's helping us to develop these applications as compared to specialists in the field. So AI applications are really going to become ubiquitous across the IT landscape. I've went to several customers already, and they're very eagerly adopting this technology. A bank I recently went to already has a few apps in production. It's moving very fast. And since Java is the language of the enterprise, it's natural for us to provide the software development and components necessary for creating AI applications. And that's what Spring AI hopes to solve. So we've probably heard a lot of news about AI in the press, and maybe you've dug a little bit deeper, but some, but not all, of the use cases that are sort of the low-hanging fruit are things like performing a question and answer chat session, but you're chatting essentially with your documents, using the information that's in your proprietary, corporate store as compared to public information. Summarizing those documents is also a very popular use case. And one thing that I think we're forgetting but starting to see more of is that it's not just generating text. It can generate code. The models can generate code, images, video, audio. So all these media types are all becoming accessible for you to use as input or output. So the Spring AI application framework is open source, and it aligns with a lot of the Spring project design patterns. So if you're used to another Spring project, you'll see a lot of similar themes here. And at heart, what we do is provide a lot of component abstractions and then default implementations. And of course, you're free to write your own implementations should there not be one that we provide. And of course, we'd love any contribution should that be the case. And in fact, we've gotten many contributions to date for different components that we weren't addressing ourselves. So portability is a big aspect of what Spring brings to the table traditionally. Right now, in a way, you can think of the API landscape for all these AI models and vector databases a little bit like what was the case before there were JDBC standard. There are all these databases that had similar but different APIs, and that's the case now with chat completion. So we provide this portable way to talk to all the different models and all the different vector databases, and indeed have a portable query language. So you don't even need to learn the query language of these vector databases. You have a very SQL-like language that applies to all of them. Multimodality is what I was referring to earlier about different input and outputs, types, different media types. I'll talk about function calling in a moment. Working with your documents means you have to do some data engineering. So we provide an ETL framework. And then these last 3 bullet points are areas we're working on now. Engines, which are basically helper classes that tie a lot of common use cases together, such as question and answer over your docs. Agents, which build upon that and apply sort of reasoning and access to tools to help solve the problem. And last but not least, evaluation, which is how do you know if your model is doing the right thing and not hallucinating. So here is the simplest application architecture, which already has a fair number of moving parts, but it's not too hard to wrap your head around them. You have the user request on the upper left hand, or API maybe, a computer is calling this. And it sends a message, basically a request, just like you type into a chat text box. That's transformed into a prompt, which is sort of the formal word for the input. And then that gets sent over to the model and you get a completion. However, even already at this stage, many of these AI models have the ability to reason, let's call it. And they can say, I need a piece of data and I don't really have it. How can I get it? And that's where you register your application's functions with the model, and then the model calls back. So in Spring, this is very easy. You just expose a bean. That's a Java util function, register it with a prompt, and it'll be called at the appropriate time by the model. Once all that's done, you get the response back. And there are many AI models, Azure, OpenAI being one of them, Mistral is another, and we support all of them as much as we can down the line. So our abstraction for chat completion requests is a class called chat client, has a simple method called call. And here I'm showing the simple string example where it says, tell me a joke. and you get a string back, which is the generated content. There's also a streaming version. So again, this request and reply interaction with the model can be synchronous or asynchronous through the flux abstraction. And there are more sophisticated prompt structures. We'll see a little bit of that later maybe, but right now, just trying to keep it very simple with strings. So to demonstrate this, I'm going to actually hopefully achieve quite a lot with a few little lines of code by use of another open source project we have called Spring CLI. It's a developer productivity tool. So you can create new applications, but not just empty shells, but new applications with code. And perhaps what's even more important is that you can go to your existing application, your brownfield application, let's call it, and add code to it. And it can do this in 3 ways. It can merge code from an existing external project. So your sample repos, let's call them. Code generation is typically done with templating. We support that as well. And hopefully we'll have time to show you how you can use AI itself to generate code. Another feature of Spring CLI, which we'll show in a moment, is user-defined commands. You can think of this as a client-side version of GitHub Actions. So typing the command spring ASA deploy orchestrates deploying the application to Azure Spring Apps in much the same way you might use GitHub Actions to run command line tools. So this is what we'll show in the demo. We'll create a new app from scratch using the Spring CLI, typing Spring Boot new. We'll add to that existing app AI functionality for Azure. And then last, we'll deploy the app to Azure using the simple Spring ASA deploy command. So I'm going to pop out into working directory. There's a lot of functionality in this CLI that I'm not going to be able to show. But we'll start off, like I said. Oops. We'll do Spring Boot new because we're getting a new boot project. We'll call it My App. Give it a package name. So what this is going to do is go off to GitHub, get a sample project, refactor that project's package name to the one we want, and put it in the directory My App. So there it is. And we'll open this up in the IDE. And we'll go to greeting controller. Oops. And you see there's a simple controller, return something. So we'll run this. So the application started. And I'll curl it, and I get back my content. That's all fun, nothing crazy. But now what I'll do is I'll do Spring Boot add AI Azure. Before I do that, actually, let me do git init. And now I'll do Spring Boot add AI Azure. So it's getting that project, and now it's doing things by merging sections of the POM. So basically the repository section, the dependency management section, and bringing over code and refactoring that code to be in the right package. So now if I go over to my POM file, oops, no. Don't know why it's not loading. Not valid object. Never saw that before. I'll open it up here. So first of all, you get a README, which explains pretty much everything you need to do, a lot of setting of keys, and then we're going to run it. And I'll look at the POM in a moment. And here's the Spring Boot starter that was added. Normally nicer to see in the diff. And add the milestone repo. And here is the Hello World application. It's asking tell me a joke. And then it's moving to the chat client, which you get through auto configuration in Spring, and just calling it and returning back information. So let's run this now. I already have my keys set up, so we don't have to waste time with that. Ooh, that is not what I wanted. Oh, I didn't make a typo. All right, starting up, and let's curl it. So it's going to tell us a joke. So here's a classic one for you. Why don't scientists trust atoms? It's because they make up everything. All right, lots of humor there. So let's go back to this. And what I'll do is I'm going to add a custom command. This is going to add the command spring ASA deploy. So I'm just going to see there's a README now. It tells you what it does, but I'll walk through that in a moment. First, I need to set some keys here. Okay. So I will now type that command, spring. Let me just do this. Maven clean package. Let's do Maven clean. All right, so spring ASA deploy. This is going to take a little while. It might have to skip over it, but essentially there are a bunch of commands in here. Think of this as GitHub Actions. So there's ASA, right? There's your Spring Apps, deploy, and in here are things that look like GitHub Actions. You're going to see it asks a question: which resource group would you like? We're going to pick this one because it's asking for all the resource groups and then setting a variable. Then it's calling AZ Spring Create, AZ Spring App Create, and finally it's calling deploy. And you see it knows information about the project, so it can substitute the appropriate Java version number in the -- runtime version option. So that's deploying. It's going to take a while, and I can already see I'm short on time. So I think I'll go back to the slides, and then we'll just curl this endpoint in a moment later. So you can see very quickly we're able to go through all that, although wish it was even quicker. So very common request is how do you use your data in an application? So AI models have limitations. One of them is they're trained with information only up to a certain date. Training these models is very expensive, costs millions of dollars and huge amounts of compute resources. So you can't run a nightly job to update the model. So if you want to ask it things that it doesn't know about, what do, right? Also, it certainly doesn't know about data it's never been trained on, right? Your data, that is your proprietary information. One thing you can do, which is sort of the machine learning angle, is to what they call fine-tune the model. This means you take the weights of this entire model, and these models have billions of parameters for weights, and you start tweaking them. This is a very specialized task. Usually not in the realm of software development, though it's getting easier. However, there's a cool trick which is amenable to software developers, which would be colloquially known as stuffing the prompt. Think of it as SQL injection, but for good. And so you add your data into the prompt, and now it can reason on that data as well. And this has given birth to a pattern called retrieval augmented generation. RAG is the acronym, three-letter acronym that is known by. So, how do you retrieve the relevant data? and add it to your prompt. There's a lot of strategies here. You start Googling for this, you can go down a big rabbit hole. So we try to make it easy and implement common strategies, and I'll demonstrate one of them now. So here's how that works for following a diagram similar to before. You have your user request, that comes in. You get your prompt, and now you have to retrieve information that is related to that prompt. This could be your proprietary information, your proprietary documents. You get that information back from some external repository. This is typically a vector database or a knowledge graph or other documents that summarize, for example, that information, and add it to the prompt. So you get an augmented prompt. I guess that's where the word augmented comes from in the A in RAG, retrieval augmented generation. You pass it over to the model, it will complete it. There's still reasoning going on there, but here I chose to highlight another capability of the AI or feature of the AI model called the context window. It's basically the amount of space you have to give it custom information. And we'll see that this is an important engineering concern because that context window is usually very limited. So then the answer comes back, and hopefully it has the information in it related to your data. Again, this context retrieval is typically done with vector databases. There's a long list of them. Most likely you have one of these maybe in your existing infrastructure. And if you don't, you need to pair up with maybe a purpose-built one. And there's a lot of selection process, and they all have great positives and negatives. So it's a little search there. So just a brief expansion on this idea of like, why are we going through all this extra effort? Context window, which is the amount of space you have to give it custom information, is very small, like 16K. So think back to 8-bit computers when they first came out. 8K, 16K, 32K, and it's getting larger and larger all the time, but still something you have to worry about. And this 16K refers to tokens. It's again another detail of the space, but it doesn't deal with words as you would imagine. It deals with numbers, and a token translates number to about 3/4 of a word. So do the math for the size of your document, and that's how much it will fit into. So really what you do is you have a lot more than 16K tokens of size. You have to chop up your data into smaller chunks and present these smaller chunks to the model. And this is typically what a vector database is used for. It has a process called embedding. So it converts words to vectors, and then you search. And it sounds complicated, but if you think of it in just 2 dimensions, if you have 2 vectors in X and Y coordinates and they're pointing close to each other, they're similar, right? It means your query and that document are similar. If they're pointing away, they're not similar. So you score it, and the way you can think of it is, the first page of Google results from a query. So if we had all the articles for Wikipedia for the 2022 Winter Olympics, we would chop them up into smaller little pieces. A lot of heuristics here, a lot of knobs to turn. That's kind of the challenge. You create these embeddings and you store it in the vector database. We have an ETL pipeline that is specifically built for this purpose based off Java functions. Lots of implementations of the reader, transformer, and writer. Won't go into those details, but the support is there for you to do that. And what I'll do is I'll demonstrate this with an example we have out of the box for a nonprofit company that we dealt with. So it was a home care service that provides the ability to have families find someone who can help with childcare or elder care, and basically think of it as a matchmaking service. And there's definitely some involvement of the government, and this is controlled with Medicaid. And more importantly, the models have never been trained on this before. And so that's the PDF document you have here. And it's in this example app under data. Oops, I want to open it up, but that's the one we were just looking at. And if you ask the model without putting information in the prompt, what's the purpose of Karina? It thinks it's a constellation in the southern sky. It is clearly not a business, right? So what we can do is create this application where is it? Yeah, Q&A. Call it engine controller. And all the magic is sitting in this engine, right? The default question is, what is the purpose of Karina? When we go to this query engine, if we open this up, what we do is, I've already loaded it, so we don't have to spend time with that. We retrieve documents that are similar to this question. We create a context, and we create a prompt, and then we call it with the prompt. And here's where the prompt simply is. It's this text, and you see it has placeholders. So prompts typically have placeholders. This is the data that it's similar, right? The context for reasoning. And this is the question we're asking over that context. So if I just run this, let me make sure nothing else is running. Start that up. So it completed. And now I will find the little thing here. So I'm saying, what is the purpose of Karina? So instead of getting, it's a constellation in the southern sky, easy to save, safe use, online care matching service. Okay, very nice. So now it knows about your document. So heading back to here. So the last little bit I'd like to show, I think I can sneak it in a few minutes, is code generation. So the models understand code really well. I mean, not many people push it to its boundaries, and I don't even think I push it to its limits either. But it knows, and Spring CLI builds upon that by writing some custom prompts and some post-processing. So you can go and say, yeah, Spring AI add, and now you say what you want pretty much, right? You type in what you'd like. What this does is it creates a README file, and you can iterate until you see this README file has what you'd like. And you can think of it in a way as a guide. You're generating a guide. And then you say Spring Guide apply. And just like the Spring Boot add command, it now adds this code into your app. So if we go here, so this is hopefully deployed now. I'll just try to do that thing. Let's see, simple. So that's calling, I guess it didn't work. Oh, well, let's go to the other stuff. Okay, so what I do is I have one of these READMEs that was generated before, because we don't have time to wait for it. And here's what it generated. So this is from a while ago, June 6th. And I just said, give me JPA functionality with an integration test. Include Java packages in the same, Java code in the same packages. So like a typical README, you have to add dependencies. Now you see it creates a person object, creates a person repository, a service, a controller, and a small integration test. And it gives you a bunch of config and some links for more information. So if I, it's already done. All right. So now if I do Spring Guide, apply README AI JPA. This will now make changes to the code base in a minute. So you can see it's added, I don't know why this thing is all messed up. But here's what it's added, right? In the right packages, has the test. And now if I do Spring Boot, Spring package, it's going to run that code, compile it, and you'll see some JPA stuff, flying by because we added JPA to it. So there's some loading of that, and it's going to succeed hopefully.
Well, Mark, I think you're making it too easy for Java developers to build Spring applications.
It can never be too easy, can it? But thank you for the comment. That's the goal, right? So I'm a little over time, I realize. So a lot of topics not covered. Of course, it's a huge space. It's evolving so fast. I can't imagine where this will be in a few years. So here are some links. And really have to say, thank you to the many open source contributors. It's, even though I work at Spring, it's been a long time since I've had such great interaction with so many people in the community. Yeah, feel free to check out our issues, or if there's something there that's not missing, or a lot of people do a lot of work on the documentation. Let me tell you, that's super, super appreciated. Even though I put it through Grammarly and ask ChatGPT to copy edit, things often aren't so clear, and a lot of people help with that. So I know it's a bit rushed, but thank you for attending the talk, and yeah, look forward to questions.
Thank you. Thank you to you for bringing this content to us and everybody watching. It was a good talk. I mean, lots of demos, and everybody, I'm sure, is engaged and wants to get the Reaper and start creating the CLI, start creating projects. Whether they use Visual Studio Code or IntelliJ, it really doesn't matter, as long as they are a productive Java developer building amazing Spring apps. So it's really cool to see that. We are at time, so Mark, thank you so much for this, and I hope you enjoy your vacation.
Okay, thank you. Sorry I went a little long.
All right, so we are back at this end of Microsoft JDConf 2024. This was the Americas edition. Thank you for sticking around and watching all these amazing sessions with great speakers from Microsoft and our partners and open source contributors and customers and so on. We had sessions about Visual Studio Code, about Java, about JVM, about AI, about cloud, Kubernetes, and everything. So there's a lot of content, and you can learn more at JDConf.com. You will be able to watch the recording of these sessions as soon as they become available on our YouTube channels. So remember, go to JDConf.com. If you signed up for this event through the Microsoft Reactor page, we will be sending you a newsletter with all the information, all the resources. If you haven't done so, go back to the website and register for the events. If you have interest in any of the content of the other editions, you're more than welcome to also watch those other events. The agenda is available, again, at JDConf.com. And we also have a survey. You should go and provide your feedback and also share your comments with us. So go back to aka.ms/JDConf/survey. And the event code is 21593. Other than that, for the Asia edition, I think that's the next edition. It's gonna start. Let's see. It is at 7 p.m. Pacific time. But it's more friendly to folks in Asia who are waking up. So it's gonna be like Asia morning time. And lots of cool stuff. One of the main presenters will be Josh Long, talking about beautiful Spring apps. So thank you for being with us. Have a good one.